Hello everyone, welcome back to Ask a Scientist Gaming, where we combine mediocre gameplay with expert level science. I'm Ken Hansen, Associate Professor in the Department of Chemistry and Biochemistry. I do all things molecular photophysics, light matter interactions, and how you can apply those to various reactions. But joining me today is Professor Hanwei Gao. Hanwei, if you wouldn't mind introducing yourself.
Hello everyone, my name is Hanwei Gao and I'm a physics professor at FSU. My research field is in condensed matter physics, or I study materials. I study light matter interaction in materials and mostly recently semiconductor materials that are useful in solar cells, for example, or LEDs, photodetectors.
All right, equally important, what game are we playing?
Bomberman, the very first version, I guess.
There we go, there's Bomberman.
Alright, this is probably gonna be the most embarrassing moment in my life. Ooh. Not too bad.
Yeah, it's off to a good start.
Thank you for the code.
So, can you explain to the audience what this game is?
If you give me one moment, I'll figure it out. Well, basically there are bricks that you need to take care of, and there are enemies that you also need to remove. Now, I haven't figured out how to win the game. My guess is there's a door, and if I take out all the components, I get a key or something. And I'm sure in the audience, we have experts.
So Bomberman, this is the first in the series. This is 1987 Bomberman, the first of a franchise. You know, there's been 45 versions of Bomberman released.
45?
Yep, across
Really?
like 15
Is this the first version?
This is the first. This is the original.
I like original.
You are part of the original. All right. So, I think it's time. You're feeling good? You're feeling comfortable? Can I open up to questions?
Go ahead. I mean, I'm very focused.
No, you have to do science and gaming. That's the point here. All right, Calm Down Bronco wants to know, I saw a recent semiconductor that didn't require ridiculous cold temperatures, but pressure instead. Why does it require the pressure?
Wait, semiconductor requires pressure?
Some do. You can get performance with pressure that you can't necessarily get. Or you can get performance with pressure that you don't necessarily see unless you go low temperature. A superconductor or a semiconductor? That's a good question.
Well, let me try to guess what the question is. As far as I know, there are semiconductors which respond to mechanical forces. I'm not sure if that's really the question. For those ones, we call it piezoelectric materials. Well, they're not really semiconductors, actually. It's mostly insulating materials, where you can produce force with electricity or vice versa. Yeah, can you read the question again?
Yeah, you made the mistake. It wasn't semiconductor, it was superconductor. So superconductors that you don't need cold, but you need high pressure. I mean, do you do any high pressure solid state materials at all?
Not particularly in my research, but I should know that.
Did you try the door? You've blown up everything, right?
Yes.
Yes. Level 1 over.
You know, to be honest, I played this game, but I don't know if I've ever passed a stage.
All right, first stage done. Congratulations.
Thank you. Well, I'm sorry. My research is not particularly related to superconductor, which is a very different class of material. And superconductor is always very important, not only for fundamental physics research, but also for applications. And people are trying to always discover new materials, actually synthesize new superconductors with primarily the objective of without the need to reduce the temperature to extremely low. for example, quantum computing, right? Right now, there has been a lot of efforts putting in the development of quantum computing, and the qubits are made of superconducting materials. So most of the quantum computers that has been demonstrated are running at a super low temperature, millikelvin. Kelvin is a temperature that is at more than minus 200 degrees Celsius. So that is very close to absolute zero, and that's how quantum computers is running now. Of course, we can do that in labs, but not really in a realistic manner.
High pressure.
So if we can actually produce more superconductors that are running at a higher temperature, we can actually make superconductors much more useful in our day-to-day life.
So Scuzzbot just linked high temperature superconductors. My favorite part of high temperature is it's 77 Kelvin.
Yeah.
So it's only like minus 200 Celsius. If you get above that, you are officially high temperature.
Minus 80 degree, because practically 77 is very difficult for liquid nitrogen. I know what you're talking about.
Yeah. That's true. All right, Reese's Pieces has redeemed a request of factoid. Do you have a factoid?
I do. Where's my cell phone?
Yeah, we take notes ahead of time. We're prepared. Cheat sheets. 3x5 note card is allowed for Ask a Scientist Gaming. Did you try the door? Can you just go through it when you find it?
You
No,
wish.
you gotta get a key.
Yeah. Factoids. Oh, yeah. I remember one factoid that I didn't really write down.
All right.
You know, we all know LCD, well, a lot of us know LCD monitors versus LED monitors. In fact, LED monitors still uses LCD technology. That is the fact.
Yes, we had generations of TVs, right? There was CRTs,
Yes.
and then LCDs took over,
Mm-hmm.
and then now LEDs and QLEDs,
Mm-hmm.
which are still LCDs, just a slight different light source.
Right. So I think in a lot of cases it's driven by branding purposes. You just want to make it easy for people to understand and remember.
Mhm.
But realistically, LCD, LED. Well, the difference between LED and LCD TV is that LED uses LED light source, but LCD is the actual display. So in LCD TV, you use a fluorescent light source instead of a LED light source, which is,
Triple kill.
I know.
Nice. That was lead.
which is not as energy efficient as LED light. So there is still advancement from the LCD to LED, but the way that the image has been generated or the display has been generated, it's really still the LCD device. Now the difference comes when there is when the OLED TV is been accomplished. In OLED TV, there is no LCD anymore, or at least in the major brand. I guess you can still put a OLED light source behind the LCD display, which I don't see the point.
Really dumb. That's a really waste of an OLED.
Yeah, can you tell me why it's not? Oh yeah.
Huge.
So in OLED TV, each pixel is a light source, which is individually controlled. Therefore, you don't need an LCD plus a backlight anymore in OLED, which makes it possible to make the monitors much thinner. and I believe that Ken is an expert in this field.
I used to be.
Well, let's say you still are.
I did review a paper using triplet annihilation on OLEDs, which is kind of interesting. But, oh yeah, Scuzzbot had the comment. It's so people think LED backlit TVs are the same as OLEDs. No, you're exactly right. Like Hanwei said, it's the branding. That's why the QLEDs is complete bullshit, in my opinion. The quantum dot LED TVs.
Quantum dot LED TV.
So they cheat. They use the quantum dot as the emitter on top of the white back source.
Oh, really?
So it's not quantum, yeah. So it's backlit, and that's the phosphor. It's not a real LED. Yeah, it's bullshit.
So quantum dot is not on TFT?
Nope, they're not individually controlled LEDs that have quantum dots. Instead, they take a backlight and they put quantum dots in front of it. And it gives you really good color purity, but it's still an LCD TV. And so their QLED TVs are not real QLED TVs.
That is interesting. Yeah. I didn't know that.
Yeah.
Well, I guess I'm learning something.
Yeah.
Okay, back to ask me as a scientist, please.
Yes. Does anyone have questions for Hanwei Gao? So joining us tonight, condensed matter physicist Hanwei Gao. He does photonics, plasmonics, light matter interactions, but does it on solid state materials. I do it on molecules. One question that Calm Down Bronco has is, have you two worked together yet?
Oh, good question. Collaboration.
Yes. Have we collaborated?
Of course. Can I join FSU at the same time through actually the same initiative?
Yeah, we interviewed for the same job, essentially, in different departments. So usually when they do hiring, they do like chemistry department opens a position and they interview in chemistry. They did something at FSU called materials, energy and materials. And they basically said, anyone that works in this area, apply. Mm-hmm. So me and Hanwei were two of the, 400 applicants that applied. And you got interviewed in physics, I got interviewed in chemistry. We got hired at the same time, about 8 years ago now.
Oh, wow.
Yeah.
Time flies.
Exactly.
So we were hired through the same initiative, which is called the Energy and Materials Initiative. Supposedly, we should work together. and that's what happened. Let me add that.
It worked out for us, yeah.
Yeah. It's our... I hope whoever hired us is not watching. Be careful about it. So we're supposed to work on similar subject, but of course with complementary skills. And that's what happened. We actually had a joint group meeting. We shared facilities. We exchanged data and discussed about the science. And you know what? Very often we can think out of box on each other's subject, but not on ourselves. That's really helpful. I mean, if you work on a subject for years, it's really difficult to think out of box because of the inertia.
Yeah, you get tunnel vision.
Yeah.
Yeah.
So yes, we did work together. We actually published papers together.
Quite a few. We're on proposals together for instruments, at least.
That's right.
Yeah, we've gotten several instruments actually.
Yeah.
Over $1 million worth at this point.
I think so. Yeah.
So
that's actually been quite successful.
Yeah. All right, Bronco wants to know, what is condensed matter? That's true. You're not an astrophysicist. You're not a particle accelerator physicist. You are a condensed matter physicist. What does that mean?
Historically, there is a term called solid-state physics. And has evolved well. First bomb with the gate open. That has evolved to condensed matter to include more variations of materials. Now, thank you. So what was the question?
Yes, you can do this. Multitask. What is
condensed matter physics? Condensed matter physics.
Well, what makes it different from other physics? Maybe we start there.
Yeah, that's probably a better way to answer that. Condensed matter physics study mostly condensed matter materials. So astrophysics studies, astronomy, or physics related to astronomy. And there's a high energy physics and nuclear physics, which is studying apparently nuclear or the high energy particles. And condensed matter physics has been focused on materials and that has been actually the driving force, or not really the driving force, that has led to the development of a lot of the useful devices and materials for the current technology. And I think one of the very or the example that I always want to bring up is the semiconductor. And we know that our current technology has been based on the rapid development of semiconductor physics and technology and actually devices over the past century. So, but that's not all about condensed matter physics. There are different classes of materials like metals, semi-metals, or insulators, or superconductors. These are all subjects of condensed matter physics.
I mean, so it sounds like it is a literal translation. Like you condense matter enough and it's something you guys are interested in.
Yeah, and more recently, condensed matter physics has been expanded to I wouldn't say it's a different class of material. It's probably a new form material that we start to be able to produce and recognize the importance of, which is the soft material. So it used to be solid state. I think that's part of the reason why condensed matter physics is now called condensed matter instead of solid state, because soft material is really at the border of solid state versus not really aqueous, but molecular type.
So you have to blow these up till you find a key?
I don't think I need a key. I think I where's...
Or you have to find the door?
Yeah, but I blow up the door.
Is this random? I don't even know this game that well. Is this...
Me neither.
Sounds like a terrible speed run if it's completely random.
But the thing is, why did I choose this game?
It's just a classic and you love it.
I do love it. I have 32 seconds. What am I doing?
No pressure, lay the bombs. Ooh, Savage Jeff has an astrophysics question. How does a black hole give off light? Do you know the answer to that?
How does black hole give off light? So, let me try.
All right.
Okay? Try from the perspective of condensed matter physicist. Oops. Black hole gives light. So, black hole has a boundary. It's not infinite. The boundary is, don't quote me on that, especially my astrophysics colleagues do not appear. Black hole has a boundary which is called horizon.
Event horizon.
Event horizon, yes. So at the boundary of that, the light can actually escape if the direction is right. So that's when the source of radiation is really at the boundary. There is a chance that the black hole can actually give light. Part of the photon is escaping or going away from the event horizon. That's that question is also related to Hawking radiation.
You need to elaborate on Hawking radiation. Oh, smushed.
I guess that means no.
Do you want the rage emote? Time to do some video game raging. So yeah, event horizon, inside that gravity pulls photons in. At the border of that, it's 50-50 depending on direction. And then beyond that, it can escape, and then you see photons. But Hawking radiation is a different sort of beast, right?
Yeah. Do I really have to explain what Hawking radiation is?
Not if you don't want to.
I think I'll make
it's
a lot of mistakes, terminology-wise.
It basically says information has to escape a black hole, right? Or something
To some extent.
Yeah.
Or it got destroyed. So basically, we assume that anything that gets into the black hole loses all its information. Which I think is still an assumption. Or I would like to hope so.
Yeah, I don't think it's been proven yet.
It's difficult. I mean, it's black hole is basically not accessible, or based on our current definition, I guess. It's like the limit of the universe, right? We don't know what's beyond that because we won't be able to know given the limit of the speed of light.
Yeah. Sorry, I didn't know you were going to be throwing astrophysics questions, but well done.
Good that I taught astronomy for
Intro to astronomy. That's awesome.
Yeah, I like that course. Really, yeah.
I mean, it's a fun, tangible topic.
And I think I motivated more students to devote themselves into astronomy research in the future than condensed matter.
Why is that?
Well, because astronomy, I think, is naturally attractive. Oh, don't.
Oh, run down.
That's an intelligent one.
Yeah, no, this is NES level artificial intelligence chasing you down. That was amazing.
I know. And I didn't think of that. I would plan a bomb earlier.
Oh, Scuzzbot Wotus redeem take a drink. Pause or get a safe spot.
Safe,
right? Yep. Cheers, Hanwei. Thank you for coming on Ask a Scientist Gaming, playing Bomberman, answering astrophysics questions.
Thank you for giving the break.
Everyone, thank you for joining us. Hanwei, what are we drinking tonight?
Yeah, I'm not going to pretend that I can read German, but it's from German. And I think it's German wheat.
It's a Hefeweizen. It's a Weihenstephaner. Weihenstephaner? There we go. We got Nightbot. Exclamation point drink tells you what we're drinking. Yeah, I can't pronounce German. I know it's Hefeweizen. In fact, the first beer I ever had was a Hefeweizen in Germany.
Really?
Yep.
The first beer?
Yeah.
When was that?
That was a hell of a trip. So you guys
you don't have to tell us the year because that may lead to some other legal issues.
No, I was 22 or something. I was well above age, even in America. I mean, I didn't drink when I was younger because unrelated family things. But so I went to Germany. Do you know the meeting of Nobel laureates in Lindau?
Oh yeah. So that was one that you.
I went to Lindau for the Nobel laureates meeting.
And that was the first time you drank beer?
So I went there with a German friend, and yeah, we were hanging out in Germany, in Lindau. And
you're a good kid.
Well, no, it was just family of alcoholics, and you don't want to go into the details of that, but like, you don't want to drink when you're in that circumstance. And so, yeah, my first beer was actually in Germany.
Wow, good for you. I mean, my first beer, I don't remember it, and I hate it, and I hate it.
Oh,
and I didn't. Well, that's.
Was it the ice beer, the really popular?
No,
Chinese
I really don't remember.
Yeah.
But yeah, it was in China, and I hate it. And after I came to the U.S., and of course I do social drinking and still hate it, until I went to Germany for the first time. I think it was in 2010-ish. And that was the first moment that I realized, oh, beer is something that you can really enjoy. No wonder, that answers a lot of questions why people are so crazy about beer.
Yeah. You don't have to do it in a destructive way, right? It's as long as it's controlled. Yeah, it was the exact same perspective. Right. Fun story about me going to that Lindau meeting. Usually you have to apply or have some special connection or something.
Yes.
Me and Karsten Bork, who were in Mark Thompson's group at University of Southern California, we heard about this meeting. We went to our Nobel Prize winner, which was George Olah, in the Hydrocarbon Institute at USC. And George, he got his Nobel Prize in 1996 for carbocation discovery, like getting an NMR of a carbon with a plus charge on it. And we went into his office and we're like, what do you know about the Lindau meeting? How do we apply? Blah, blah, blah. And he says, I will talk to you guys later about this or something. And like 3 days later, we got an email from somebody at Lindau that said, of course, we'll accept your students to the conference. And so George just like sent an email and said, you should accept these two to the conference. And that was it. So that was our secret handshake. He didn't know us. He was just like a nice guy that helped us out.
Impossible.
So yeah, I was in a room with 33 Nobel Prize winners in chemistry.
Yeah.
Like you rub shoulders, you like have dinner with them. It's pretty amazing.
That's awesome. I only have heard about those things.
Yeah. And it was just because George sent an email. And his email was something along the lines of, I expect you will accept these students and cover their costs while they're there. And that was it. So thank you, George Olah. Shout out.
Beautiful.
All right, back to the science question. Maximus01 wants to know, how are perovskites used in ultrasound machines? I did not know they were used in ultrasound machines. That is interesting.
No, I don't. Well, wait. Depends on which perovskite that you're talking about.
Point. That's a good point. So let's define general perovskites and then buzzword perovskites.
Yes. So, well, I guess it really depends on what the question or whoever asked the questions means about perovskite. And let me talk about the hot topic perovskite, which is happen to be my research field now. It's a class of materials that's been developed in recent decade. It wasn't really discovered in recent decade, actually, much longer than that.
It's the 1970s, right?
I think so, yeah.
70 like the modern AB, the lead ammonium iodide.
Yeah. But the good thing about the perovskite, the perovskite that I'm studying, and which is also the popular subject in the past decade, is the halide version of perovskite. So the more traditional perovskite is chalcogenide, which is mostly oxide. Let's put it that way. Oh, did I make a mistake? No. Okay. So halide perovskite is optoelectronic, or it responds very nicely to light. So it's a class of material that people use for solar cells, LEDs, photodetectors, anything that you can take advantage of light matter interaction in applications. Okay. I'm not aware of this class of material, meaning the halide perovskite, being used in ultrasound. I'm not so sure about the oxide version though. But halide perovskite has been used a lot in detectors. And one of the, I think, is most promising field, in addition to solar cell or photovoltaics, is the X-ray detection. It's really sensitive and it's really cheap to make. So you can make an X-ray detector out of these materials in a much lighter weight, much less material, with higher sensitivity. And you know what that means to the patient? Is that they really don't need to get that much of radiation, which is of course harmful to the healthy tissues before they can get diagnosed in the same quality as the previous generation. So I think that is an aspect that not many people are working on in the field of perovskite, but I think that's certainly an important branch of the research, if not more important than others.
Yeah, so I'll give the broader definition of perovskite, at least the chemical perspective on it. So perovskite it's a form of crystal. And so it's anytime you have a formula that's ABX, where A, B, and X are three different things and the X is a halogen, that is a perovskite crystal. And so those have existed they're natural perovskites. They are like in the 70s, they were really big.
In minerals.
Yeah, in minerals, right?
So I think typical, it was actually almost like another name for calcium.
Oh, calcium carbonate.
Yeah, carbonate.
Calcium carbonate is a
calcium carbonate.
It's ABX form. Yeah. And so it's a huge class of materials. And recently, the definition has been like hijacked by the lead ammonium iodide perovskites, because it's really popular for LEDs and solar cells. But perovskites in general have been used for a long time. And so presumably in the ultrasound machine, it's used as a piezoelectric, where it's a particular crystal lattice that has favorability. So when you apply electricity on it, it vibrates really fast. And that's what actually creates the sound waves. And so if you want to do an ultrasound and see like a baby, you have a crystal that does that vibrating.
Oh.
And then you have a crystal that receives those vibrations, and when it vibrates, it generates electricity. And so you can turn that electrical signal into a visual signal.
So ultrasound detector is based on piezoelectric?
Yep.
Okay,
Yep,
that
exactly
explains, because a lot of the perovskite, a lot of the oxide perovskites are ferroelectric and piezoelectric.
Yeah, so that makes perfect sense.
I didn't know that it's made of piezoelectric.
Yeah, I will never forget that. So when I first started college, I started athletic training, and I distinctly remember the most profound thing I read in my athletic training book was how an ultrasound works.
Wow.
They're like, there's a crystal, it's a piezoelectric crystal that vibrates when you apply electricity to it.
That makes sense.
Was like, holy shit, I need to dive deeper. So I went to exercise science, then biomedical, and then finally chemistry. So yeah, Ken's origin story related to piezoelectric crystals.
That's why we need to talk more.
Maxi Minimus, thank you for the question. That was awesome. Brought us down a rabbit hole. All right, Bronco wants to know, how does physics research differ from chemical research? Is it the approach? Is it the techniques? Is it the materials? What makes you and I different?
That's a very good question. I think the same question applies to how is chemistry different from biology. I think it's in my opinion, the division, well, of course, these fields share a lot of common interest, and people in these fields collaborate a lot with each other. I think the division appears when we're talking about the level of complexity. So chemistry studies system that is more complicated and probably closer to the practical life applications to some extent compared to physics. Physics pursues extremely simple, or we actually try to simplify the system or the subject of study as much as we can, so that we can isolate the variables and only try to understand the effect of one variable at a time. So that's why we want to simplify the system or the problem. Oh, I can control the bomb now. This is cool. And chemistry is
Oh, you can tell it when to fire?
Huh.
Nice.
Without a wire.
It's remote detonation. Cell phone based. 1987 cell phone. His entire body is a cell phone. That's awesome.
So I don't know if you would agree with my interpretation of difference between chemistry and physics.
I don't know if I'd say complexity, but more of like level of abstraction or something, like how
That as well.
many, like you were right in the number of variables. Like as you climb up the ladder of science from math to physics to chemistry, biology, psychology, sociology, blah, blah, blah.
Yeah.
The variable soup gets bigger and bigger.
Uh-huh.
And so isolating variables. With that said, Hanwei and I do very similar things. You could easily have been in a chemistry department. I don't know if I would have fit in a physics department, but
Me neither.
we both should have been material science. Anyway.
Yeah. I have my degree in material science.
So your PhD is material science?
Yes.
So Terry's
in chemistry.
okay.
And I was a material scientist student. And I worked in Terry's group, Terry Odom, Department of Chemistry in Northwestern University. And I study physics problems in a chemistry department as a material science student. So that was my complicated background.
So related to that, we're going to throw a prediction up on the board. So guys, spend your imaginary internet points right now. If you're not following, click the follow button right now. Get your 300 standard internet units. We're going to have a bet right now. The question is, how much has Hanwei made in the last year on patents?
Oh, I'm glad that you put that in the first.
And so that's from graduate school patents, right?
Well, let's assume so.
Let's assume so. So the question is, how much has Hanwei made in patent royalties in 2020? Was it less than 4,000 or more than 4,000? So there's no real way you guys can know this answer, but let's see if you're optimistic or pessimistic on how useful Hanwei's research has been.
I like that term.
Because we had this discussion with Staircase. Thank you for the Prime sub. Again, welcome to Ask a Scientist Gaming with Hanwei Gao. We were trying to guess how much patent royalty Hanwei won in 2020. We had this conversation with Steve Leonard. We have a clip where he says, no, you can't just have patents to make money. Because I have dozens of patents. So you do have to have a patent that actually hits it big. And so Has Hanwei made money off of his patents? Greater than 4,000, less than 4,000? Throw your guess in right now. How much time? We got about 45 seconds left. Oh, we got 3 people saying greater than 4,000. Nobody wants to guess less than 4,000.
People are being nice.
No, they're optimistic.
Okay.
Oh, no, we got 1 saying less than 4,000.
That's probably from my field.
Interesting. From your field. What you do is useless. If you've made any money off of it, it's reasonably useful. At least you've sold the vision enough that someone can actually do something useful. So, oops. Alright. We got a couple seconds left. Alright, Hanwei, so we got 70% of the betting is that you made more than 4,000, 30% of that you made less than 4,000.
70% is more than 4,000?
Yep.
I'm flattered.
The actual answer is...
Of course no.
Of course, no, less than 4,000. So how many patents do you have?
I think I have 3 in total.
So
No, 4.
3 patents, and how much money have those patents made?
0.
Oh. So sorry, believers, your faith in Hanwei was misplaced. He has made $0 off of his patents. Harsh.
That's fine. You know, that's that. There is a reason I put this as a prediction.
Was that?
Well, I think there are 2 aspects that I want to tell people. One is that really science to me is not about money at all. I mean, I'm not against money, to be honest, but really that's not why I chose this as my career. So that's one. The other is that patent is not always there to make money. In a lot of cases, is to hope that you can make money. You protect the you protect the technology, and then you believe that this would be useful. I don't know what's the percentage of patent being actually used in technology. I don't think it's extremely high. But that is a desire that you want to make something useful. And whether the market is going to take it and whether people or a consumer would like to use your product, it's a different story. But it's more of a hope and a desire to make something useful.
What's even crazier than that, if you have like an actual lawyer write up a patent and submit it like we do at FSU at other universities, it's something like $5,000 to $10,000 to get a patent. So even if you get a patent, the percent that actually make money beyond that threshold is relatively low. So it's a matter of luck and circumstance. That's a fun question. But speaking of which, so I did get my patent check this year. I actually have a couple patents that make money, and it's not too much money, but it is enough money for it's okay. You want to rage?
No, that's fine.
Okay.
I like it.
We'll do a rage emo.
It's all right.
And so, yeah, and it costs money to maintain patents as well. But so I got a patent check this year, which Debbie and I have negotiated as just free spending for me. And so we only have 2 emote slots right now for Ask a Scientist Gaming, and we need 50 subscriptions to get 5 emote slots as affiliates. And so what we're going to do tonight is we're going to drop a whole bunch of sub bombs from just personal funds. And so if you guys are here and you want tier 1 subs, it is time to get your tier 1 subs for free from Ask a Scientist Gaming, because we're going to get those 50 subs tonight, and we're going to get those 5 emote slots. So congratulations on those of you that just had a tier 1 sub dropped on you from Ask a Scientist Gaming. We are going to get all 5 emote slots because we need Mr. Big to be in tier 1, and we need a couple new so yeah, congratulations again to all of you that just got gift subs. Enjoy your emotes, enjoy Ethanol and Rage, and eventually we'll add Mr. Big and a few more to it. So thank you for joining us, and enjoy your gift subs. Cheers. No, Mr. Big is not tier 1, but it will be as soon as I can add those other 4 or 5 or 3 additional slots. I'll put Mr. Big as tier 1. So yeah, that's going to be exciting. So sorry. On my way, I distracted completely, but
Oh, that's okay.
So that's where my patent
I'm enjoying my
goes
game.
towards gift subs on Twitch, as well as getting us emotes. And Mr. Big is coming, yes. You guys can actually see a game list if you do exclamation point games. There we go. So there's the list for the night if you guys want to see what's coming up. All right, let's go back to some of the questions. What are, if you don't mind me asking, what are some or both of your patents in? What are your patents in?
Two is about the perovskite material that I am studying still.
Oh, these are recent ones.
Yeah,
Okay.
well, two of those are recent ones. The other two are, one is for nano patterning. It's a way to pattern nanometer, or actually somewhere between nanometer and micrometer structures on surface using fairly inexpensive ways with high precision. And to be honest, there are a lot of different variations of those out of the market, which it really depends on the infrastructure and the market and the technology, and to make any or none of those useful. And the last one is about a sensing technology that we use plasmonic structure to sense gas molecules. I personally think it's a very cool technology, but to be honest, there are a lot of alternatives. Some may have merit some sense than others. So again, I think whether a technology would actually take off and be available on the market, it's not all about the merit of the technology themselves. With that, I can give you one example, is that everyone knows that our current semiconductor technology is based on silicon, but is really silicon is the best material, or is the most suitable material for these purposes. If we only consider the performance of the property of the semiconductor, germanium could be another one, which is very similar to silicon. It belongs to the same group 4 elements. It has the direct band gap. I should probably not use any of those jargons. But it just has better optical response. But it doesn't get to use really a lot in our consumer products. It's used in some of the scientific instruments.
That's stressful. But the first transistor was germanium, wasn't it?
Yes.
Yeah. That's how.
But the problem is that it's much more difficult to obtain high or acquire high quality germanium materials. And silicon, we know that we have a lot of sand or silicon oxide. You can just reduce the silicon oxide to silicon and purify it and make it a high quality material, high quality wafer for chips. So all of the infrastructures has been built based on silicon technology and silicon semiconductor chips. That's why it is the most popular semiconductor nowadays being used.
Follow up on that. Oh, sorry, I missed a couple. Savage Jeff and Melty Kiss, thank you very much for the follow. We appreciate you joining us here at Ask a Scientist Gaming. And the questions you're throwing as well. I promise we'll get back to those. We detour for a bit, but I have them all in a Word document. We'll get back to them. But calm down to follow up on the patent question. My patents, at least the ones that make money, are I have a couple on solar cells, organic photovoltaics, and then the other one is on organic light emitting diodes. And so if you bought like a Samsung phone or an LG TV that uses OLEDs, I probably got 0.000000000001 cent from that. So
that's significant.
It's enough to pay for gift subs on Twitch, so I can't complain too much. But yeah, I have a few more patents here at a few from my postdoc in here, a few from FSU, but those I haven't made any money. I have one for isomerizing molecules to the left-handed or right-handed using light. I have another one on triplet annihilation solar cells, some on electron transfer, some on separating lanthanides and actinides with light. And
wow.
So, yeah, pretty applied in terms of light applications. But we'll see if any of them actually make money in the future.
So, A related question.
Yes.
Sorry to interrupt.
Let's go.
Did you spend all of your royalty back to the OLED?
So last year when I got a patent check, I bought an OLED TV. So it practically pays for itself. So it's awesome.
Good, good. I'm glad that you also contribute.
All right, back to the physics question. Savage Jeff wants to know, do atoms have color?
Oh, that's a hard one.
Yeah, that is a non-trivial.
I want to say they do, because you can actually take spectroscopy out of atoms, especially if you put certain atoms into crystal. They do emit light, so in that sense, atoms do have color. But if you talk about individual atoms in a free space, meaning a vacuum, I think it's going to be challenging. And now, as a physicist, I'll have to define what color means, because are we talking about visible, spectral range, or are we talking about all electromagnetic waves? If the latter, yeah. So generally speaking, I would say atoms do not have color, but if you put atoms into certain circumstance, then yes, atoms have color. There was something.
You can force atoms to emit color too. So if you have gas phase atoms and you apply electricity or you put enough heat, they will glow colors. And that's how fireworks work. Does that bomb the entire length of the path?
I think so. I'm getting super bomb.
Huge.
Oh, I can do that? Oh. Why didn't you guys tell me that?
Yeah. Where's the coaching from chat? Oh.
Now there was something else I wanted to.
Polymers rule redeemed. Take a drink. So, Hanwei, cheers again.
All right.
Man. It's a pleasure to have you, everyone. Thank you for joining us on Wednesday night.
Thank you for joining.
Hopefully you have a beer in hand, maybe a Hefeweizen, maybe something else. But cheers to everyone. Thank you again for joining us.
Do atoms have color? That's a cool question.
Yeah, it's a really fun question.
Was that from...
That was from... Oh, I deleted it. Give me a second. That's from Jeff Savage. Or Savage Jeff.
Savage Jeff.
Sorry. Savage Jeff. All right. Reese's Pieces wants to know, speaking of beer, what's the physics behind different colored beer bottles, green, brown, dark, black, in terms of blocking light? What are certain wavelengths that might be okay to let filter through?
You should probably guess about that, the answer.
So I have an actual answer. If you
Oh, you do?
Yeah.
Okay. Go ahead.
And so the reason you use brown bottles is if you use transparent bottles with beer, there are certain sulfides and things in them that if they get shined with light, they make new molecules. And those molecules are like taste bad or they're destructive to other things in the material. Did you just walk through that wall? Mm-hmm. How did that happen?
Well, because I'm good.
All right. You got a superpower. All right. But anyway, most of the bottles you want brown because it's going to drop. This is going to block out the entire visible spectrum, right? You can't see through it. You're not going to get red, greens, and blues through them. You can get away with green bottles because that only lets through the mid-energy light, but it blocks out things like blue and UV, the stuff that typically does those damages. But if you have a transparent bottle like Corona actually causes the light that goes through it actually causes those sulfides to form.
You mean the virus?
No, coronavirus as well as beer. You can use light to kill the coronavirus as well. Yes, there's a talk about this at IAPS. So IAPS is the Inter-American Photochemical Society. And so one of my colleagues at Bowling Green University, Malcolm Forbes, he used to be at UNC, he does something called electron paramagnetic resonance, which is basically an MRI for electrons. And he showed that in beer, when it's exposed to light, it makes certain very specific radicals. And these species are very similar to what you find in cat piss. And so if you actually expose certain beers to light, it makes a cat piss byproduct. And so that's why he calls Corona cat piss beer. It gives people a hard time whenever they drink Corona around him. And it's because the light's not blocking out those... or the bottle's not blocking out those photons, and so over time you're generating those byproducts that are from cat piss, essentially. So yeah,
interesting.
Fun factoid and detour that I know probably way too much about. But yeah, that's the same reason. Like, if you look at isopropyl Alcohol, if you buy like nail polish remover, it's a clear bottle because they don't care if light goes through. But if you have something like hydrogen peroxide, it comes in a brown bottle. And it's because visible light will actually decompose those peroxides. And so if you expose it to light, it decomposes over time. So
That's cool.
have fun. All right, so yeah, that's... So the short answer is you can let through most greens and reds, but you don't want blue and UV for the same reason you don't want blue and UV on your skin. It's high energy and it starts damaging, but the other stuff doesn't as much. Staircase 73, what were the instruments you made? Was that part of the patent-related discussion? You used sensors, I guess. Was that instrument-related?
Not, well, one of the sensor, I think it's instrument related. It's the one that we pattern metal surface with nanostructures, periodic structures, so that we can detect gas molecules with higher sensitivity. And I think that's the only one that is instrument related. Yeah.
So what level are you on? I've not been keeping track.
12.
12. All right, here we are at level 12 of Bomberman. Joining me tonight is Professor Hanwei Gao, who's an expert in condensed matter physics. He does all things photonics, nanophotonics, plasmonics, perovskite LEDs, perovskite solar cells. If you have any questions for Hanwei, throw them in chat right now. Or if you have any questions in general science you'd like to talk, throw them in. Questions about Bomberman, probably don't ask. We don't know what we're doing. So
I'm at 12, level 12. Come on.
like it.
This is probably my record with Bomberman.
Nice.
You know, I used to be... I used to not like this game because it's so boring. You just basically plan all the bombs and just try to kill these little things, what I don't know what it's called. Yeah, I hate this game, but my best friend liked this game, so we still played. I never told him that I hate this game.
So you didn't invite him to watch.
Yeah, that could be a good idea. So I always like died early and he was like enjoying the game.
We're gonna use up some of our predictions. Let's start another prediction. Is there one you want in particular?
I think they're all good. Solar wings.
Alright, do this one. Alright, we're gonna throw another prediction on the board. Use your imaginary internet points. If you're not following, follow right now. Also, if you stick around, we're gonna have more gift subs coming out just because we want those emotes lots. So Bomberman gets intense when it's 4-person multiplayer and everyone's trying to trap bomb everyone. I can see that competitive Bomberman. Alright, so the prediction is up right now. The question is, globally, was there more energy produced from solar or from wind? So, was there more solar than wind, true or false, is the question that's on the board right now. So, again, globally, in terms of the production of energy, did solar beat wind, true or false? 4-person multiplayer bomber. That sounds like a good time.
Have you ever played the Bomberman Nintendo Switch version?
Mm-hmm.
That is intense.
You could have brought that over. We could have played that. Next time.
Next time, yeah.
Alright, so questions on the board again. In terms of energy production, was there more solar than wind? True or false?
Time 1 second.
Stage 12. You got this.
13
Alright.
to correct you.
We have something like 40 seconds left. Again, question is, energy production globally, was it more from solar than wind, or the other way around?
What's the current poll?
It's the current poll. I will tell you in a second. So 73, right now 73, you got to poker face this because we don't want to reveal anything. 73% say false, 27% say true. with 4 people voting false, 2 people voting true.
How's my poker face?
I have no idea. They're trying to get meta information from me. All right, the poll is closed. So Hanwei, more solar than wind energy globally in 2020, true or false?
False.
False. It's more wind energy.
The comparison is actually marginal. So
Really?
it is a little more wind energy than solar.
Globally last year,
Yeah.
wind beat solar in terms of
Yeah.
energy.
But in total, renewable energy is still quite limited compared to other sources. The fossil fuels, well, I guess right now, currently, most of the statistics divide the fossil fuels to oil, natural gases, coal, and other fossil fuels. That's still the majority, which leads to emission, the greenhouse gases emission.
So congratulations for those of you that said false. You said wind generated more energy than solar. You are 100% correct. I mean, that's either way we win. Like, as long as wind and solar are getting better,
Yeah.
that's a huge contribution. Anyone that tells you solar is going to solve the world's problem is lying. Anyone that tells you wind is going to solve the world's problem is lying. The answer is a combination of all of them.
Right.
And that includes hydrocarbons. We're still going to need fossil fuels to run certain things. There's no question about it. So,
Well, for a certain time, yes, I think that's going to happen. All right, that's going to remain that way. Obviously, climate issues or greenhouse gases emission control is always a hot topic, maybe too hot. Getting more political, especially under the current globalization process. But regardless, there are conspiracies about climate change or global warming. As a scientist, we don't really exclude. That's okay. I'm still alive.
all right.
We don't exclude any possibilities. We're not saying that anything is 100% for sure. Speaking about that, we can only prove that it's wrong, but never can prove it's right. That's the scientific principle. But in any case, what if it's true? What if the climate change is real? What if this global warming is real? That is not destroying the Earth, it's actually destroying the habitat of human beings and other living creatures on the Earth. Earth is robust.
Yeah.
Let me tell you that. This is what I know very well after teaching astronomy this semester. Earth is robust. We cannot destroy Earth.
Well, that's why I think it's funny when it's like save the planet. Like, the planet's going to be fine.
I know.
It's the stuff on the
it's
planet.
us.
It's not going to do it. The planet is not going anywhere.
Yeah.
The Earth does not care about your feelings. Exactly. The Earth is a very robust thing. Life finds a way as long as it's in the habitable zone of a solar system.
That's right.
Wipe us all out. Something will come in the future. But if you want to keep your quality of life, then that probably matters.
Definitely. And also, we live with other creatures on the Earth. So we can't just, think of ourselves only.
Right, Hanwei. So we are approaching the 9 o'clock.
Good.
Do you want to change to Double Dragon?
Long want it.
You want it?
Yeah.
All right, we're shifting up games. Bomberman, say goodbye, everyone. I know it was an exciting
Level 13, record.
Level 13 in 1 hour. I think the speedrun record in it is about 12 minutes. All right, we're going to another classic called Double Dragon. Actually, this is Double Dragon 2, The Revenge. Calm down, Bronco. Thank you for stopping by again. 5 a.m. lab date. Have fun with that. Guess summer session C is going. Good luck with your semester classes. But yeah. Well, Big Spooky Skeleton has redeemed request a factoid. Do you have another factoid?
I did.
All right, for those of you just joining us, 9 o'clock, we've been here for an hour. We're Ask a Scientist Gaming, combining mediocre gameplay with expert-level science. My guest today is Dr. Hanwei Gao, a condensed matter physicist, does things nanophotonics, plasmonics, light matter interactions, the physics of those interactions, as well as LEDs and solar cells, broad expertise in those areas. But back to it. Let's go.
So in 2019, there are more than 300 billion chips, semiconductor chips, sold worldwide. 300 billion. That's about 40 chips per person. Worldwide, poor or rich. So that's a huge number. And that, to some extent, indicates that how important the semiconductor technology is.
What did you say the number was?
300 billion.
300 billion.
Chips. I'm not talking about elements.
Yeah, not transistors. You're talking
Yes.
about actual chips. So there's basically, what is that? 300 billion, roughly 20 chips for every person on Earth.
40.
40 chips for every person on Earth. Holy cow, that's a lot of chips.
Mm-hmm.
Hey Rob, you guys might have noticed another 10 sub gift bomb. Me and the moderators have coordinated. Yes, we are getting our 5 email slots tonight. So congratulations on you that got your gift subs. Alex, thank you for doing that. Yeah, enjoy your emotes. You guys get Ethanol and Rage, and eventually Mr. Big and a whole bunch of other emotes. Join Discord if you haven't already. The link is there in chat. In particular, we're interested in ideas for emotes and various other things. Emotes, also guests. If you guys know any professors that want to play video games and talk science on camera, let me know. Because it's a non-trivial task to email random people to find someone that plays video games and wants to talk science. So if you guys have ideas, email them to me or join the Discord again.
Whoever wants to join, think twice.
Why? Is it everything you thought it would be?
It's intense.
It's hard.
I know. I don't know what I'm talking about. Or I don't know what I'm playing.
So this one you played a bunch before too.
This one?
Yeah.
Yes. This is actually my favorite Nintendo. I don't know what generation it is. This is really my favorite. So I picked my favorite and least favorite.
LT Kiss wants to know, how many chips does a computer or cell phone have? Oh, wow, on the spot.
How many chips?
I mean, so the motherboard counts as one chip, right?
Well, if you're talking about CPU chip, that's one. Well, maybe multiple. But if you're talking about chip in general, there are a lot. Because CPU is just, one kind of chip that you have on each computer. So, good question. I don't have the answer. And I think it really depends on the level of complexity of the board, the function of the device. My guess is cell phone is not anywhere less complicated than a computer. At least not anymore.
So Scuzzbot Woda says dozens. He's a computer engineer, so he might have good perspective on this. The other question is, how many chips does the Nintendo have? The original 1983 NES system. I don't know that answer.
How many chips? I don't know.
It might be the same number, actually. Just has less elements per chip.
Yeah. Thank you for the answer. Thank you for the question, which make me regret it too.
It's a good factoid, though. Like,
Yeah.
chips outnumber people.
But that was totally not my intention to invite that question.
That's what makes Ask a Scientist gaming fun.
You have a great audience.
Yeah, no, that's a really good question. All right, so let's go with the. Yes, Dr. Gao's glasses keep reflecting and go invisible periodically from the green screen. Yes, we don't have a good way to fix that. It's just
we do.
Reflect. Oh man, it's going glasses free. I like it.
Now play better.
Can you actually see how bad is your vision?
I can see.
No, you can keep the glasses on.
That's
just
fine.
an observation. Yeah, I have to remind guests not to wear green shirts because it's not something that comes up in your day-to-day life. But yeah, the glasses angle is something we haven't figured out yet. I don't know how to fix that. If anyone has good ideas, let me know.
Well, Let me try to think about that.
That's pretty good. All right, so I have a question for you.
Yeah.
6-year-old Hanwei Gao wanting to play video games, but his parents wouldn't let him. Obviously didn't think he'd be a condensed matter physicist. What led you on the path that got you?
Well, not playing video games.
You take that back. I played obsessively for like 35 years.
Well, because you're good. For me, yeah, I have to quit video games before I can do anything. That's just, of course, kidding. I continue to play video games, but not for a lot of time. I think, so what brings me here? I think that's the curiosity. I'm naturally curious about physics problem. I clearly remember when I was a kid. Yeah, I'm curious about a lot of things, especially physics problems. I remember when I was a grade 8, I think that was the first time I had a physics class. And there was a chapter number 6, still remember.
You remember the chapter?
Yeah.
Awesome.
Chapter number 6 is about force analysis. So it's mechanics. Okay. And after that, I analyze any object that I can see in my life, like cars running, rain droplets that's falling. So anything that I can observe in my day-to-day life, I analyze them, and I can draw the force analysis, you know, the gravity, the support, the buoyant forces, all those. So I think the curiosity really is the biggest contribution, which made me a physics professor. And other than that, being tough. I think that's also. I mean, science. I guess you probably would agree with me that if you are not really into science, science can be really frustrating.
Yeah.
Because literally, our work is about how to handle failure.
Consistent failure, repetitive failure, day after day.
But if you think about it, that makes sense, because we're trying to discover something that is new, and we have no example to follow. And of course, we are wrong in most cases.
Consistently, yep.
Yeah. So I think being able to handle this frustration and failure is essential for being a scientist. And I think that's true for scientists in general. Not necessarily professors.
That's very true. I tell my grad students that. Like, I remember 4 or 5 distinct victories as a grad student. Like those euphoric moments where it like actually worked, and the rest of the time was failure and troubleshooting.
Yeah.
Good times in the sciences. Jessica Fleur, thank you for the follow. Again, welcome to Ask a Scientist Gaming. Jessica, if you have any questions, throw them in chat right now. Dr. Hanwei Gao is happy to answer anything about condensed matter physics, photonics, nanophotonics, plasmonics. These look like some contra spikes there.
Mm-hmm. I don't remember this part.
That's fine. You're doing well. Note that we also have like infinite lives in here, so Hanwei jumping into the ceiling and dying is okay. Did you ever figure out how to knee people in this?
No, not yet.
Brass knuckles, though. Nope. That's an explosive. Never mind. Alright, so speaking of questions, nanophotonics, which I think Latin translates to, I don't know, little photons or something, but it really means, when you say it, it's nanostructures and how it relates with light. And so what does that
What is nanophotonics
mean? Yes,
in general?
What is
well, I think to answer that question, I need to introduce the concept photon first. So photon is a form of light. If you ever heard about particle wave duality of photon, light is wave duality of light. Light is particle, light is wave in the meantime. So in certain cases, we'd like to treat light more as a particle than a wave. It appears to be wave more than a particle. Sorry, what I'm talking about. This is the part that I'm not very good at, so forgive me. Okay, good now. So when we in the cases that we like to treat light as particle, we call them photons. Okay, it's not a breakable particle that has a certain energy with it. Now, any material that responds to photon,
These gangsters are carrying around maces. It's just a casual street weapon, you know. Anyway, sorry.
what
Photon.
particle photon? Okay. Yeah. In any cases that we'd like to treat light as a particle, we call them photon, and the devices that respond to these kind of particle is called photonics or photonic devices. So nanophotonic devices is the devices with nanostructures. Nano is a word that's been misused a lot, and
Ooh,
did I swing?
I don't know. I don't know what the hitbox is for that platform. Anyway, nano's misused.
Yeah, nano's has been misused a lot. There's no clear reason why nano is nano is certainly not a discipline in my mind, and but it's a subject that that can create a lot of new phenomena simply when the dimension is small. That's why over the years people try to differentiate it from the conventional large-scale materials or devices, which I think it's just a name. Don't really think too much about, you know.
Well, so it's a hijack name, right? So nano literally just means 10 to the 9.
Yes.
So you could have nanoliters, you can have nanoseconds, nanometers.
True.
When you see people say nano now, they mean nanometers. I work in nanoseconds or faster, but yeah, nanometers is where the buzzword of nanotechnology came into play. And so, yeah. So nanophotonics is
a photonics that contains nanoscale features.
Yeah, and so nanoscale features interact differently with light than a macro scale or meter scale.
Right.
So yeah, that makes sense. So a follow-up question on this one. A guy from Discord, from our Discord server, posted a question. What are some possible real-world applications and/or research opportunities of photonic nanostructures related to space? Either near-term...
Photonic nanostructure?
Yep. In terms of applications in space, either short-term or long-term. So this is there.
Oh.
He's giving you patent ideas, right?
Yeah. Nanophotonics. Well, one application of nanophotonics,
Well, it's before answering the space question, what's like a normal day-to-day application of nanophotonics? Is there any...
for example, waveguide.
Yeah.
Okay, if you want to transmit light at a very small scale, you would like to create waveguides in a small scale, which can fall onto the nanometer scale. Okay. So that's one of the that's actually a future direction of the application of nanophotonics is that you can use that to create waveguides that are so small so that I can integrate it into chips and make it into photonic chips. So right now, most of the chips are made of semiconductor materials for with electronic applications or properties. But we can actually use light to process information, and those are called photonic chips or photonic circuits. And Nanophotonics is the platform we can realize that idea.
Yeah, waveguides is a good one. I mean, fiber optics, those aren't waveguides, but
They are waveguide, but not necessarily at a nanoscale.
yeah. No, that makes sense. So guiding light, directing light for optical, rather than using electrical transistors, use optical.
Yeah.
Yeah, that makes sense. So that's broadly applicable to all computers, including those in space. There are other things like reading a CD would count as nanophotonics, right?
Yes, if you make the CD small enough, yes. Nanophotonics, well,
Depends what the feature set is, right?
exactly.
Yeah.
Yeah. And nowadays we always want to make things smaller because I mean for the integration purposes. So wait, did I finish all of things?
No, mission 6.
Um,
Ooh. Do we have Infinite Live against Spikes? We're gonna find out. The answer is yes, ladies and gentlemen. We have Infinite Lives against Spikes. So Double Dragon 2 is interesting. Anyone that cares about Game Genie is that it doesn't have an Infinite Lives code, but it says it has codes that say spikes won't kill you, water won't kill you, volume won't kill you. So we apparently have the spikes won't kill you code in. So congratulations. Yeah, survive the jumps.
so back to the question about what would be the application of nanophotonics in space. It's not only for space, but I can give you that question is for power transmission. So one application or one idea that people have been exploring is to use nanophotonics devices to transmit power. To some extent, the wireless charger is within the region of or area of photonics because you're transmitting power by electromagnetic waves, which is really a type of photonic device. Now we can make it either more efficient or with different wavelength of the light that we use to transmit power, and that'll what am I doing? That'll require nanophotonic devices. Another interesting application would be if you ever heard about that was very popular during my graduate school time, is the invisible cloaking or Harry Potter.
Yeah. The negative refractive index.
The negative refractive index.
Yeah.
Yes. Theoretically, it's true, and at some wavelength, it's been demonstrated. But it's not as beautiful as what you saw in the movie yet.
So we don't quite have Predator yet. We're working on it though.
That's one thing.
I haven't actually looked into it. How did the remote charging apparatus work? What wavelength are they using, and how do they generate power from that absorption?
I don't know about the market product, but you can definitely do it by microwave or terahertz.
Okay, so some source generates terahertz or microwave waves. Those are absorbed by something and generate heat, or is it?
No, it's the induction between
creates,
between the two.
So the field of light coming through creates a current in some kind of coil or something, and that generates electricity. That's interesting.
Yeah,
I've never had a wireless charging device. I probably should get one at some point.
try that.
Fun
I was amazed at how quickly it went up to the market. Apparently, it's not a subject that's been studied only recently, I guess. Am I ever gonna finish this? So typically, it takes much longer.
Oh,
I know. It takes much longer from academic research to the actual product on the market. So I believe that the wireless power charging has been studied for quite many years. And development cycle. I mean, speaking about that, I think perovskite is going to break the record as a class of semiconductor.
That's interesting. So first perovskite solar cell was
2019. It's a Jack's paper.
2019. No, it was earlier
Yes,
than that.
that was the very first.
2009.
Oh, sorry, 2009. Yeah.
Okay, yeah. 2009 was the big breakthrough. Bell's Tech, welcome to the stream. Have questions for condensed matter physicist Hanwei Gao? Throw them in chat right now. So perovskite 2009. So the materials existed a long time. 2009 was the solar cell breakthrough paper. Are there commercial perovskites?
There are the so-called small production line. It's still considered as a prototype.
Like we could buy a perovskite on. It just wouldn't power our house, right? It would be a like personal solar cell, similar to what DSSCs are basically. Yeah.
Yeah. I think it's very, very close to being commercialized or like, you know, a product that you can easily buy. But again, whether the market is going to receive it well, it's really a business question, which I don't think we should discuss a lot here.
Because we know nothing.
Yeah. But scientific or engineering wise, I think it's obvious to me that it's going to take on.
Yeah. I mean, as long as you can encapsulate it, right? As long as you can protect it,
it's still
stability.
It's already pretty good.
Yeah. So it's going to be big. And the lead content is low enough that people aren't super worried anymore.
People are worried. I'm not.
Yeah.
It's not as many as you would think, because all of these are super thin devices. So
this is the hardest part of the game right here. This is like the Mega Man moving platform. Bell's Tech, thank you for joining us. Hanwei, you can't read this, but Bell's Tech said, I don't know anything about physics besides the basics, but it's still cool and listen and pretend I understand what's being talked about. Hopefully some of it's accessible enough. Again, general questions are the most fun because they're the most profound, right? Specific ones we answer all day, but ask us the color of an atom and just...
I know.
Mind's blown.
It's a great question.
Anything you're curious about Bell's Tech, light matter interactions, what makes an LED work, Hanwei is happy to answer it. Just like graduate school. Yeah, that's 100% true. So Hanwei and I are on a lot of each of our students' committees, and the questions that devastate students are not the like very specific research ones. They're the very general ones that you should learn from like introductory Gen Chem or introductory physics. And just, yeah. So ask your questions if you have any, throw them in chat. Reese's Pieces has a very important one. Which Double Dragon protagonist, Billy or Jimmy, would break the most expensive lab instrument? So the blue one is Billy, the red one is Jimmy. Hanwei, what is your answer?
Billy.
Obviously. Why Billy? Player one. Billy is the Mario of Double Dragon World. So Scott's dad got asked, who in the Mario universe would you rather collaborate with? And his answer was Luigi. Holy crap, we got this. Oh! You did it. You were so close.
Who asked the question at that moment?
Sorry, Reese's Pieces. You've distracted Hanwei. The answer is Billy. But that does relate to a question we usually ask is, what's the most expensive or dangerous accident you've seen in lab?
Oh,
mistake or accident.
Let me use an example that, of course, didn't happen in my lab. My lab is the safest ever. When I was in Berkeley as a postdoc, of course, there are safety trainings, and a real life case that they brought up to scare us is an incident related to compressed gas cylinder. So if you don't strap your compressed gas cylinder to a safety feature, like to the wall or any anchoring or any anchors, there's a chance that they would fall, and that incidence is related to one of the falling. So what happens is that that cylinder fell, and the tip of the cylinder, which is the valve, knocked off on one of the granite table, and essentially that cylinder became a rocket. So it went through horizontally through that floor, and then got lifted up, not really lifted up, but standing up by itself because of the pressure. It's hitting the external wall, and the external wall is much more, much stronger. So it didn't really break through that wall, but it stood up and then shooting downward across floors. So I don't think that incident led to any casualty, but
There's some remodeling.
But yeah, obviously that's really something that scared me, and I'm sure that's going to be expensive.
Yeah.
Not only
sound, that had to be really loud.
Yeah.
Like that's destructive. Holy crap.
I think I believe that happened in LBL.
I'm sure it's happened many places. It's not an uncommon mistake, that's for sure.
Yeah.
So that was the most dangerous, most expensive. Nothing happens in your lab?
No.
I suppose you guys don't do syringes too much, or people, holy crap.
Oh
Yes.
yes.
Well done, sir.
Can I get another beer, please?
Yes, you can. You've earned it.
Deserve it.
You earned it.
Thanks much.
What a battle.
I swear I wasn't this bad as a teenager.
No, Reese's Pieces said first try. Well done.
Yeah.
Oh yeah, that merits some ethanol. Cheers, everyone. Thank you for joining us. Hanwei just beat Mission 6. He's on to Mission 7. Double Dragon, where Billy would break the most equipment in lab.
Absolutely.
Oh man, speaking of success stories, we do need suggestions for emotes on victory. So we have Rage, we have Mr. Big for mass destruction. We don't have an emote for success. So we need a good game emote related to science or Ask a Scientist gaming. So if anyone has suggestions, join Discord and drop those suggestions in. We're looking forward to them. Because tonight we are unlocking 5 emote slots. So we're going to have Mr. Big plus Ethanol plus Rage plus a couple others. So throw your suggestions in Discord or send me an email. Either are fine. Speaking of which, I think we're due for another 5 gift subs. Alright. Alright, congratulations to a whole bunch of people on that list. Again, enjoy your tier 1 emotes. They're going to be 5. It's going to be 3 additional emotes as soon as I get done with submitting them after this stream. But for now, enjoy your 2 Ethanol and Rage emotes. And Bells, again, thank you for joining us. Congratulations on your tier 1 sub. Alright, anyone else? 9:30, we're about halfway through the stream. Does anyone have questions for Professor Hanwei Gao? Any questions relating to condensed matter physics, photonics, plasmonics? We haven't talked about plasmonics at all. What is plasmonics and why should I care?
Plasmonics is a subset of nanophotonics, in my opinion. Some others may have different interpretation. So it's a type of photonic structures that is made of plasmonic resonances. I used to be, just call it metallic nanophotonics, but now a plasmonic material has been extended a lot from metals to semiconductors, for example. So dare not to just call it metallic nanophotonics anymore. So it has a lot of the near field phenomena. Near field meaning it's very close to the surface of the nanostructure, within the dimension of an optical wavelength. Why do we care about that? Again, this is also a very fundamental issue that it produces phenomena and properties of material that are not conventional, that we don't get to observe previously. That's why we're interested in that, and that's thank you.
Oh, get it. Yes. Damage boost. Can somebody clip that, please? That was amazing. Your lifeless body got thrown onto the next platform. Well done. We call those victories on Ask a Scientist.
Yeah.
Luffy Gamer, thank you for the follow. Clearly you're following for the quality gameplay of Professor Hanwei Gao, and not just for the science discussion. But Hanwei's here to talk plasmonics, photonics, and play Double Dragon, which is a non-trivial task. This is a hard game. This is one of the early beat-em-ups for NES that was huge. This game was loved.
Yeah.
Scuzzbot, thank you for the tier 1 sub and the 6-month streak, one of our earliest subs on the stream. Thank you very much. Luffy Gamer, again, if you have questions, throw them in chat right now. Hanwei is happy to answer them. Mostly condensed matter physics, but we are happy to discuss any science topic because that's what we do all day. It's just kind of fun.
Yeah.
Not gonna lie, I love my job.
Of course, we say love our job in public, right?
Yeah, this is all recorded. This will be on YouTube, so yes, I absolutely.
Yeah, definitely. We love our jobs. All right, that's just a joke.
Good enough.
But yeah, this is a great job. I think this professor is a blessed job. You got to do interesting things, or you're paid to do interesting stuff. And can I say that we get paid well?
We paid reasonably well. I mean, we started at what, 83,000?
Something like
professors.
That. Yeah.
Which is kind of funny because my first graduate started at 125,000 or something like that. So there are better ways to make money doing science, but we get flexibility and freedom, which is pretty amazing.
Yeah.
Scuzzbot, thank you for clipping the damage boost across the platform. That's awesome. Hanwei, you can watch your highlights later.
Thank you.
We are due for another prediction, Hanwei. What do you want to do? We got 4 of them left.
I need my glasses.
Where are your glasses?
US, UK per capita.
All right, let's do that. All right, we're going to throw a prediction on the board. Those of you that are not following, click the follow button, get your standard internet units, your imaginary internet points that do nothing outside of the stream. But in stream, they allowed you to cheers and like have us take a drink. You can unlock emote slots. You can also, let me throw this in here quick. Sorry about that. All right. Oh, Polymer Rule, thank you for the tier 1 gift sub, getting us closer to our count of 50. We are going to hit that 50 mark tonight. Don't worry about gift subbing. If you guys are going to sub to our channel, do it through Amazon Prime. It's free. If you tie your Amazon Prime account to your Twitch account, you can basically have Jeff Bezos write us a check directly. Don't spend your money on us. Well, do if you want to. It pays for beer money as well as eventual Uber rides home for drunk scientists. But tonight, again, our goal is 50 subs because we're going to unlock 5 emote slots, so stick around if you want one. Hey, Rob, thank you for the clip as well. Pro gamer move is what he called it. The platform death. All right, so we've thrown a prediction on the board. That prediction is related to energy consumption. So US versus UK. So in terms of per person energy consumption in 2020, did citizens in the US consume twice as much energy or less than twice as much? More than twice as much or less than twice as much? And so this is the UK versus the US. And so, what inspired this question?
Energy.
Energy is a big thing.
Yeah. Well, my research is closely related to sustainable energy, and I think it's not about how we generate energy, it's also about how we consume it.
Yeah. I mean, and so that's not a trivial, like, 2 times as much energy consumption is a lot.
Yes,
Like,
it is a
not
lot.
a trivial difference.
Right.
And so the question is greater than 2 and less than 2. This is the US versus the UK. So this is average energy consumption, right? This is car driving, this is household lighting, this is everything.
Yeah.
Which is not easy math to do, but somebody has done these type of analyses. So again, the question is US versus UK per person, was the energy less than 2 times or greater than 2 times in 2020? And so I'll give away part of the answer. The US per capita consumes more energy than the UK. The question is it more than twice as much or is it less than twice as much? I mean, per capita, the US is more than any. I mean, I think that's...
Well, I'll address that later.
All right. We're about to find out last second. All right, Hanwei. US versus UK per capita energy consumption in 2020. Do your average Americans do more than 2 times or less than 2 times?
It's more than 2 times.
More than twice as much energy. So on average, you and I consume more energy than a...
Shall we stop playing game now?
Twice as many? Why?
Save energy.
No, I think the lighting is costing us now. But so how much?
Is that LED light?
Yes, all 4 of those are LEDs. Yep.
Yeah. It's roughly 2.2.
2.2 times as much energy if you're a US
capita?
citizen per capita to UK.
Yes.
And so what's driving that? Do you know what the main contributor?
I don't know. So my intention for this prediction was that just to raise the attention about how much energy we're actually consuming in the US per capita. But then I thought about it, without knowing the actual purpose of the energy, we can't really say that we're wasting more energy. So let's not go that far.
That's true.
You can very well argue that the U.S. industry is more active than the U.K. We don't have any U.K. audience here.
I can check after. We'll see if we offend anyone. But
Yeah, but that's just an example. I mean, there could be other explanations for that. But regardless, I think we should just do more study and try to find out where is the energy being consumed, and if we can actually do better. Because if we put a lot of resource and efforts in studying renewable energy and try to generate energy in a carbon-free manner, in the meantime, we would also want to consume the energy in a wise way. Part of my research is related to, or your research also is related to LED, which is a more efficient light source. That's one way to save energy, per se. So back to your assumption, U.S. is actually not the highest on the list.
is it really? What's highest?
It's a small country. Oh, it's what is the strait of Mediterranean? The strait to the Atlantic Ocean. Gibraltar?
Somebody in chat know the answer to that? Yeah, there's a lot of discussion in chat right now. Questions about transport, because the relative size of the country, right? U.S. is mostly empty space. You have to transport over large areas. Huge energy consumption.
Yeah.
Reese's Pieces, a large must be AC and heating. Reese's Pieces Strait of Gibraltar,
Yes.
they are a higher energy consumer than the U.S.
It's extremely high. I don't know why though. I didn't really study like the source of the energy.
Huh.
But as a major country, I think New Zealand is also much higher than the U.S.
Wow.
I don't know if it's because of their agriculture, which certainly consumed a lot of energy.
Yeah, polymers ruled. The UK was developed with 4 cars, not a lot of parking lots, more people walk. Yeah, no, that's the thing. Like
That's
US,
the general case in Europe. In Europe,
yeah, US was built after we needed space for cars, so we have all cars intersecting our cities. Walking is abysmal. Public transport is terrible.
yeah.
Yeah, and UK is also tiny.
The infrastructure is very different
You did it.
between the yes. Oh, did I?
Yeah, you just beat Double Dragon.
Huh?
Congratulations.
How much time? Did you time it?
I didn't time it.
Did I break the record?
I very much doubt it, but we'll throw Boss Man up on the screen there. Congratulations
I certainly-
on Double Dragon.
I certainly break my record.
All right.
The second record in a row today.
Personal best, Hanwei Gao. A little bit of cheating going on. Congratulations on your victory. Oh, also, Alex Robb has assured us the U.S. were fine because all of our energy is generated from clean coal, and those are molecules of freedom. So, sure, that doesn't cause any problems in the environment.
Thank you. That's a peace of mind. Now we can continue to play games.
That's another thing. The pitch from all those gas and coal companies that are like, turn off your lights and if you leave the room, turn off the light. I want everyone to understand how small of an energy consumption that is compared to transporting gas across like an ocean.
Transporting, I think I saw the number. I was actually surprised how much energy in total that we're still putting into lighting. It's still ranked number 3 or 4.
Yeah, it's like 30%.
Yeah.
But most of that still is industrial. So it's like street lighting and parking garages
right?
and businesses. Yeah.
Okay.
Like household consumption is very, very small. So they try to put the onus on us to save the planet. Like there are bigger fish to fry. Replace all those with LEDs and we're in the right step. All right. So we're on to what game now? Is it time for some Captain Commando?
Oh, yeah. Oh,
Stepping
wow.
up to NES or Super Nintendo system. All right, ladies and gentlemen, this is Captain Commando. I don't remember the year on this one. This is like 1992. Capcom.
Something like
games.
that I have some kids' money to spend, and I spend all over them.
So your description where you're like, my parents didn't let me play was a complete lie. You just went to the arcade and played anyway. All right. Captain Commando. Who are you going to be?
Well, so
Baby Commando
we're
is
not,
the speedrun strat.
Never mind. I just need to break my own records.
All right.
Again.
Do you want a timer? We can put up a timer.
You just need an iPhone that roughly time it. I think that's precise enough.
We need an actual timer. All right. In the corner, we have a clock for Hanwei Gao playing Captain Commando, beating it in speedrun time. All right. Julinium wants to know, what is your opinion on artificial obsolescence when it comes to energy devices like light bulbs?
Wait. Sorry.
Artificial obsolescence. So, like, there are companies, like, I'm 100% confident Apple does this. They make their products die in a certain time window, so you have to buy new ones. So it's not the intrinsic lifetime, it's just artificially created to kill the lifetime of those things.
For the purpose of
selling more, making money.
Okay.
I think I know your opinion on this, but
disclaimer. Anything like that is wrong. We should not do that. Well, I'm sure things like this. You know what? I really don't want to believe that manufacturers does that.
Well, they do.
I still hope that it's purely conspiracy and
yeah. I don't know about like LEDs and energy related products, but like they do it with cell phones, with computers, with any tech they want you to replace every 2 years. Like there's literally court cases about them slowing down software so you need to buy a new cell phone.
Really?
Which is kind of crazy, yeah. And so that's Captain Commando. LED lamps die due to heat. Yeah. Thermal damage over time. Not a lot of heat, but it's enough. All right, we're at 9:44. Anyone just joining us, Dr. Hanwei Gao is playing Captain Commando, but also asking questions about condensed matter physics, solar cells, LEDs, photonics, plasmonics, anything light matter interactions you might want to know. Between Hanwei and I think we have all of it covered. So light matter is kind of our thing. I do molecules, he does solid state. But yeah, we know a lot of it. There was a video by Vertasium, which I thought was interesting, presumably talking about that. Julinium, you can whisper it to one of the mods. They're going to check out any links before they post them to chat, but if you whisper them to the mods or to me, preferably the mods, because I'm probably not going to watch it right now, but yeah, feel free to throw that towards them, and then yeah, we'll share it in chat. But yeah, Ask a Scientist Gaming, we have Captain Commando as well as Condensed Matter Physics. Throw your questions in chat now. But before anyone asks, I'll throw one out there. What is the most memorable moment of your scientific career?
Oh, my first paper.
Yeah?
Yes. I think that changed me. So that was in graduate school. I think I started my project in the winter of 2004. That's about one semester after I joined the graduate program.
Yeah.
And I did the same experiment for a year and a half. And I remember I got, it was really just one little technical issue that I didn't even include in the paper. Eventually, it worked. I guess it's partially luck that it worked. So that leads to the publication of my first scientific paper. And I remember that was an afternoon, about 2 p.m. And I straight went up to my advisor's office, and she was in a meeting. Well, something. She was in the middle of something, and I insist that she came with me to the lab, look at the data, and she appeared to be excited too. Not sure whether she's really excited or just don't want to discourage me.
Yeah.
But
that's a bold move as a first year. Well, I guess you were second year then.
That was the end of the second year.
Yeah.
But you know, I almost gave up on this project because after a year and a half of repeating the same experiment, I really don't think it would work. But it did. So now that I think about that moment, I'm still excited. I still remember all the details, not just because that paper. It's because that's when I know about how science works or how scientific research works. I think we talked a little bit about this, is that you know, how to handle frustration and how to handle failure, because that's what you are supposed to get on a daily basis. 80% or 90% of your life, it's about failure in experiments or research. But for that moment, I think it's worth it, and that's the first time I enjoyed that moment.
Yeah, you get 4 or 5 of those, right, in grad school, and that's awesome. That was your I made it moment. Not getting hired as a professor was the first paper.
So yeah, I think that defined me, or that defined me as a real scientist from that moment on. Maybe not a very competent one yet, but really I think this is something that I can do. This is something that I like doing, and all the frustration, all the, you know, the overnight working hours, all worth it then.
So it wasn't the first paper, it was the first like publishable result you got. It was that moment then.
Yes.
Yeah.
Yeah.
That's awesome because you knew it was big. You knew it enough to
Well,
bet your
that experiment is pretty much the
credibility
first paper. I think all of the data that I include in the paper is from that afternoon.
That's awesome.
Yeah.
That's crazy to get that. Like, I mean, you had all the controls ahead of time, presumably, and
Yeah.
that's awesome.
So you learned that nothing is waste. I mean, all the year and a half of efforts before that led to that moment.
That year and a half sucks. Make no mistake, any of you grad students in the stream know.
And I also tell my student that I understand their frustration in a lot of cases, because especially for the junior grad student, because they had no experience and they didn't know what kind of excitement they are looking for. They are waiting for them there. So once you've done it once, and then you become an experienced adult.
It's pretty amazing, bad guys. A Rob says, I read somewhere Apple admitted they do it with cell phones. When the batteries start to degrade, they lower performance due to the lack of battery. Also, if anyone's interested in watching the video, Julinium suggested that's also Scuzzbot just posted that. Also, A Rob, thank you for the 5 gift subs. We're getting closer to our 50 sub mark. Yes, we're going to open all 5 of those emote slots tonight. So again, thank you anyone for swinging by. You are going to get your gift sub tonight, so stick around. Tier 1, unlock Ethanol as well as Rage, and then 3 more sometime in the next week or so. So unrelated to science, Captain Commando. What is this game is near and dear to your heart because
I spent a lot of money on it.
so this is an arcade game that was later ported to Super Nintendo.
Oh, really?
So you played the arcade game, presumably.
Yes.
And so
Too bad. I should have waited.
Yeah. So you went to your local
Like the game room type thing. Yeah.
Like it was an arcade.
That's. Oh man, I should.
How old were you when you were playing this?
I should not tell you that because my parents wouldn't want to know.
Your parents are not watching Twitch right now. And they won't watch YouTube later, so you're fine.
I think that was close to my middle school, I think. End of elementary school and beginning of middle school.
That's a good time to be playing games.
Yes,
So Scott Stagg pointed out something very important. Back when we used to play video games a lot, we were rarely drunk while doing it. So cheers to being almost 40 or 40. I actually don't know how old you are, but cheers to being
I'm not telling you.
40-ish and drinking alcohol and playing video games on a Wednesday night. Thank you all for joining us.
Thank you. This is wonderful.
Playing Captain Commando, burning people alive. Some quality gameplay.
And I'm gonna have to spend a penny on it.
Yeah, exactly. Infinite lives.
How great.
We should have done the math on how many quarters you would have wasted on the number of deaths here.
I'd like to use ice cream cups.
What?
It's the ice cream that I wanted to have, but I rather spend on games.
So parents gave you money. Have some ice cream. Thanks, Mom. Mom said I could never make a living playing video games. Well, look at me now. It's true. That's amazing. I like it. All right, Ask Scientist Gaming. Anyone just joining us? Hanwei Gao, Photonics, Plasmonics, LEDs, solar cells. We're happy to talk about anything. Throw your questions in chat right now. While playing Captain Commando. Well done, sir.
Thanks. Sorry.
The boom mic strategy. Oh. Here we might have woken up the 2-year-old.
Did I?
No. We'll see. What are the biggest challenges in your field right now? What's the holy grail of perovskite related research?
Well, of course, for perovskite is the stability, although it has been improved a lot. There's still room to go. if I mean seriously, if if the issue of the stability is can be overcome, you'll see the product very soon on the market. And I think one of the 50% of my efforts is actually devoted to the stability of perovskite. Not just a material, but also for the device. Yeah, the interface between the perovskite and other materials. That's a realistic issue.
This is a chemistry, material science, engineering. Like, it bridges a lot.
Pretty much.
Is there going to be a solution, or is this going to be case by case basis?
I believe. Well, I'm always kind of pessimistic on my research. I use different tone of language in proposals though, but I don't know if my research is going to present a solution, but at least it'll show something that would not work. In a lot of cases, that's really my perspective about research. Is not to show what is working, but also show what is not working and why. I think that is important. That leads us to the answer for the next stage.
Just want to point out, you just were in a room that was like Minion Fight Club, where they were watching in the audience. You beat up their buddies. It's pretty great.
I would never pay attention to that. To the background.
Another boss.
Oh, this one is difficult.
I mean, so that's what's crazy. If perovskites were stable and they had the breakthrough in 2009, that would have been it. Like, that's all it would have taken to do a commercializable thin film solar cell.
That's crazy. That is, if you ever paid attention to the development of solar cells, efficiency, the roadmap, it took decades, like 3 or 4 decades, before the silicon solar cells is viable. And within 10 years of efforts, perovskite is beating the efficiency of solar cells. That's impossible. And what's amazing about this class of material is that usually we would study the property of the material, the fundamental property of the material to death. Like, we know about the material 100% before we can actually make it useful. And perovskite is the total opposite case. That for some reason, you just can't make it wrong. It's so robust, it's so easy to make, and it performs so well that... So
I'm going to actually show you guys this image. This is the... let me see if I can get this up. I cannot. It's not letting me show that browser, but... Yeah, it's crazy. It's like a vertical slope on perovskite. Silicon took 30, 40 years to make that problem.
Yeah.
Absolutely crazy. Let's see if I can bring that up.
Which year of Unreal is that?
I'm trying to find a recent one. Where's it going? Alright, so there it is, the efficiency map. I don't know how high resolution this guy's, if you can see it, but starting over here is 1975 going to 2020. This is cell efficiency over time. And so a lot of these high ones up here don't really matter, but there's like silicon travels this journey. Perovskite is the one like right over here. You can see this really sharp increase in efficiency up to, what is the final? 25%. It's just crazy progress over the last decade on perovskites. And like dye-sensitized solar cells completely plateaued. Organics are increasing, but perovskites just blew up and surpassed everything. So absolutely crazy growth.
So here's a question for you.
Yep.
Since you're working on dye-sensitized solar cells to some extent, what do you think would be the future given the presence of perovskite?
I don't think there is one. I think the only place dye-sensitized solar cells will occupy on a commercial market is low lighting solar cells. Like, so both silicon and perovskites, you need a certain photon flux for them to be efficient. Dye-sensitized solar cells are linear from the ground up.
Okay.
If you want to run a solar cell inside a house, dye-sensitized is the way to do it.
Okay.
So there is a low lighting application, but that's the only. And there's also some high voltage solar cells you can do if you want a particular application, which you can't do with silicon and perovskite. So
High voltage?
yeah, like if you want a high potential driving cell
Okay.
for certain specific applications, you can do it with an OLED.
Well, silicon, there's not much you can do, right?
Yeah.
Because the band gap is limiting the actual voltage that you can,
Yeah.
perovskite, probably there's more room to play with because you can actually tune the band gap to, within a certain range. But I guess it's probably not up to the, the voltage that the dye sensitized can do.
So I mean, there's niche, but like when perovskites came on, I saw the like, I didn't work on DSSCs anymore. I work on molecules and interfaces for various applications.
Yes.
So I've changed my pitch in terms of what we do. But
Good idea.
Same science, but different pitch associated. So yeah, it's all about how you sell your science. We can do the same research for many different applications. All right, Reese's Pieces has redeemed to take a drink. So Hanwei,
all right.
Cheers to everyone. Thank you for joining us on Wednesday night. Hanwei, cheers.
Cheers.
Captain Commando speedrun. You're pausing. You're killing your record time right now.
That's fine.
The clock is still running. Captain Commando who has a flamethrower for a mouth. Or is it his mouth or it's his arm?
What's that?
Is it his arm or his mouth that's throwing flames?
Arm.
My favorite part of this game is that they name the henchmen. Like you can read their names up in the top left corner, associated with their power bar. So you're beating up Z and Wookiee right now. Okay. Ninja Physics wants to know, so on the note of clear solar cells, are they scalable to put on market?
Clear solar cells?
Transparent solar cells and solar windows, waveguides, indoor transparent.
I've noticed the prototype of those. I'm not sure. Again, this is more of a commercial or business question. I don't know what is the status of the product for those transparent. As a matter of fact, a perovskite is one of the materials that people are trying to develop for the application of transparent solar cells, because you can tune the band gap, because you can control the thickness more easily. There's a certain demand for that kind of application because there's large area window in buildings, right? So you can actually harvest a lot of energy while you avoid heating, the solar radiation heating through the windows. So it's really a multi-purpose application.
So I've seen some analyses of that, and there's a very rare circumstance where you'd want a transparent solar cell. Like it sounds great on buildings, but you need to have a building where the angle of lighting during a certain portion of the day is worthwhile. And so it's very specific. It's typically like high latitude where you can do like 24-hour sunlight, and it's at a certain angle. So there are uses, but like I think most of the time it's not going to be. Like you could cover New York City with transparent solar cells. I don't think it solves your energy problem.
No, I don't think it's really for the purpose of completely supplying the electricity that you would need in that building. It's just, if you can generate some energy while you're blocking the heating source, there's still point to do that. Especially if you can reduce the cost of the solar cell, why not, right? So I don't think it would be a major source of energy in any sense.
Yeah, makes sense. I mean, there's going to be utility there. The big pet peeve I have is the solar roads. I don't know if you saw that buzz.
Solar roads?
Yeah, like making road tiles that were solar cells. Yes, that is as crazy as it sounds. It was like this big fundraiser they were trying. It was a startup company trying to make roads that were solar cells. But like asking a solar cell to be a road and a solar cell is non-trivial. And it's solving a problem that's not really a problem for most of the country, at least in the US. We're not limited by land. We're limited by actual solar cells and putting them on land. So but putting them on roads doesn't help you or solve your problem. Yeah, you can do the cost benefit analysis, and it is not effective to make a road out of solar cells. No matter how good they are, it's a stupid idea. Don't invest in it. Anyway, Reese's Pieces has a fun one. If a science fiction writer asked you to suggest what life would be like in 100 years, what from your research would you suggest is a possible way the future will be different? How is your research going to change the future? Maybe not your research specifically, but like your area of research.
Well, if we really expand my research to condensed matter, and I would say quantum computing would be part of my field.
Are you breaking into quantum computing? Are you thinking about going that route?
I've been following literatures. This is certainly a future direction, or the future, in some sense. Speaking about that, I can tell you that I'm actually not a super fan of high tech. I think that's some kind of philosophical question, like, you know, what does technology really does to us or did to us? Are we happier with with all these high tech?
Oh, I see. That's more philosophical.
Yeah.
Like, should we live in caves? Should we?
I think that's probably another extremity, but computing power has been changing our or communication speed has been changing our lifestyle a lot. You know, people always talk about, you know, nowadays we sit at a table, we don't talk to each other, but we chat to each other.
Yeah.
By a phone.
Yeah, we stare at a screen all day.
That's right.
Are our lives better?
Yeah. Now, when supercomputer or quantum computing comes to the way, artificial intelligence will be like more literally artificial intelligence rather than the concepts. So how would that change our life? I really can't imagine it. And I wouldn't say if I would look forward to that.
Yeah. No, 100 years is a long time.
Yeah.
Like 100 years ago, we're Great Depression, right, in the United States. Like, we're struggling to get bread. We also have prohibition. Like, people can't, like, just barely have discovered flight. Electricity starts to permeate. Plumbing starts to permeate. I don't think we have the creativity. That's why I love science fiction writers, because they, like you talked about earlier, having that external lens, like just knowing enough about state of the art now to project into a crazy world we can't imagine.
I know.
I love it. Like, I would love to see like a Dyson sphere around the sun, right? Something harvesting sunlight directly near the surface, but yeah, that's pretty crazy.
Yeah. So some of the sci-fi writers are really good. They can predict the world pretty well.
That's true.
There was one from France. I don't remember his name, or maybe I just can't really pronounce his name in French, but he's the one who wrote is that the journey to the
center of the
center
Earth?
of yes.
Yeah. I remember the author behind that.
And he also predicted the space shuttle, or not really space shuttle, but the rockets to the moon. Yeah, he
got a lot right.
Yeah, he got right on things.
Yeah, Isaac Asimov too. A lot of predictions about, you know, robotics and AI and all sorts of stuff that I'd argue they're better than us. We should read sci-fi and try to like write proposals around it, because they're going to be more creative than we are.
Oh yeah.
Jules Verne, thank you, Reese's Pieces. Yes, Jules Verne.
Oh yeah, Jules Verne.
All right, a solar cell follow-up question. Would you say now is a good time to upgrade to solar for your home, or is it better technology in the pipeline that's worth the wait? Oof.
You mean for energy supply?
Yeah,
For household?
powering
Household?
your house, yeah.
Okay. Of course, wait for perovskite.
Wait for Hanwei's patent to make that. I mean, it's not going to be that different in cost, is it? Than silicon right now?
Well, actually, the device cost is not a major cost. It's the installation.
Yeah.
And so maybe marginally. It depends on the architecture of the device that they built. Maybe the installation is much easier. Maybe it's roll-to-roll, it's soft substrate that you don't really need to install the heavy panels anymore. You can just, it's like a carpet that you roll on to your onto the roof, or like the Elon's idea about
Solar
integrating
tiles.
Solar tiles.
Have you seen those? Have you seen them implemented?
No,
They actually look pretty good.
really?
Yeah.
Elon is a very
Here, I got an image link for you guys if you want to check out solar tiles. So there they are on there. Yeah,
That's
it's
cool.
pretty classy. Like,
Yeah.
that's a really nice. I mean, but the hard part is you need, again, the right angle on your house, the right, certain time of day, and not having trees on the sides. There's certain restrictions on it, but they look really good.
That's
Like
pretty
even
cool.
compared to 5 years ago, the solar tiles are they're really.
But seriously, to answer that question, I think it's never too early to install solar panels on your roof if your HOA allows it.
If your homeowners association is okay with solar panels, because really it is. I mean, if you have the upfront cost, it's cost parity with your other power source. Like long term, it will pay for itself. It's just, do you have a 10-year investment plan?
Yeah.
Do you own your house and will you live there for that period of time? It is probably worth it.
And also in Tallahassee, we have hurricane seasons which last for half of a year.
Yep.
And any of that moment, you can lose your power.
Yeah, exactly. Like we have a colleague in chemistry who has solar panels on his house. It supplies 60% of his power or something like that. But again, during a hurricane, that's absolutely priceless. That covers your power consumption.
Yeah.
But yeah, if you can afford the upfront cost or have some program to do it and your house is solar viable, there's a couple websites, I don't remember what they are, but they actually look at like a Google Maps view and say, based on your location, based on the tree coverage in the area, is it cost effective to have solar cells or not? So yeah, if you meet those criteria and you can afford the upfront cost, long term, it's definitely, yeah, non-trivial upfront cost. So those solar, the solar roof that I showed, it's something like 50 to 90,000 to install it. So
Wow.
yeah, I need a new roof too. I mean, if you're exposed to sunlight, it's probably worth it. That's the crazy part. And I mean, you also need some electrical infrastructure in your house too. So you need the batteries to store it and the electrical to transpose it, transfer it, and all sorts of stuff. So yeah. But they are looking pretty good. As long as a tree's not going to fall on your house, because that would be devastating.
That's right.
So Hanwei, you are on the last level of this game.
Are we?
Yep, this
Wow.
is it. We're on the spaceship.
I'm pretty good.
Yeah, we better throw up another prediction. What do you think? Commercially available cells?
Oh yeah, let's do that. I like that one.
So speaking of commercial solar cells, we have a prediction for you guys right now. We're going to throw it up. If you're not following, click follow, get your 300 standard internet units. Gamble them on predictions that we're going to pop up on the screen right now. And that prediction question is, are there greater than 30% efficient solar cells that are commercially available? And so solar cell efficiency basically describes the photon to electrical efficiency. How many light units, which are photons, are converted to electrical efficiency. If you go to Radio Shack and buy a solar cell, it's going to be like, 5 to 10% efficient. Well, Radio Shack doesn't exist, but the toy solar cells. But in terms of commercial cells, can you buy a greater than 30% efficient solar cell? Is that commercially available? Yes or no? Throw your predictions in the chat right now. You have about 1 minute and 15 seconds. Again, if you're not following, click follow. Use your standard internet units that are pretty much useless but fun anyway. Make your bets now. Can you buy a commercially available greater than 30% efficient solar cell? And by buy here, I mean a regular commercial purchasing process. People have made in lab greater than 30% efficient, but can you buy them? Are they commercially available?
So what do they get if they're right?
They just get so basically here you can see a payout. So it pays out, you know, if twice as many people bet for one than the other, then you get a 2-to-1 payout on your internet points. And so
okay.
you can redeem things like request a factoid, take a drink. They can unlock one of our emotes. It's just it's imaginary internet points.
Interesting.
So, but it does feed the endorphins, the Vegas response, the slot machine. So yeah, people like betting on internet units that don't really matter but are kind of fun. So the question is there a commercially available greater than 30% efficient solar cell? Yes or no? So 5 seconds left. All right, Hanwei, what's the answer? Can I buy a greater than 30% efficient solar cell?
The answer is no. You cannot buy solar cell that's more than 30%.
No.
commercial.
Congratulations, those of you that predicted no. Cannot buy a greater than 30% solar
What's the
cell.
poll?
So it was 3 people voted for each, but the people that said no bet 938 standard internet units versus 130. So it's heavily favoring no, and they got a 1.14 payout.
Congratulations.
So congratulations on the no's. Why can't I buy a greater than 30%?
Well,
Oh, this is the last stage. I thought the spaceship was last. My mistake.
it's all right. I don't remember anyways.
All right. So why can't we buy a greater than 30% efficient solar cell?
Now, first of all, there is this question is tricky because strictly speaking, you need to define what efficiency you're talking about. And generally, people talk about energy conversion efficiency is how much energy that you received in form of photon or light, and how much energy you're generating in form of electricity. So we use semiconductors to generate photovoltaic or solar cell energy, or solar energy. Because of the characteristic electronic structure of the semiconductor, we naturally lose a lot of the light, the energy of the light into heat. That's just how the material works. So even if you get 100% quantum efficiency, meaning one photon, one electron that you can generate, you still get up to 35% or 34%ish. That's a very well known quantity in the solar or photovoltaic community. So you got 30% of solar cell doesn't mean, or close to 30% solar cell doesn't mean that the device is poor. It's already the theoretical limit that you can possibly get. Another aspect that that limits the efficiency of the solar cell is what type of semiconductors are available there for you to construct solar cells. Does it match with the solar spectrum? The answer is there's always a little bit of mismatch. So the best that we can do by far for silicon is about 25%-ish. And that's also the limit of perovskite solar cells. How much we can improve this device? We don't know. Maybe for another few percent, but really speaking about the energy conversion efficiency, there's not much room that you can improve. But that doesn't mean that the development of technology is over. In a lot of cases, we have to make the device viable. We have to make sure that you buy a device that can last for years, and that's a lot of engineering efforts behind it, behind the scene. So yeah, 30% is really the number that people in this field is pursuing. Now, if you paid attention to the
NREL, National Renewable Energy Laboratory, located in Colorado. You pay attention to the NREL chart that can just hold up. There are solar cells that can possibly exceed 30% limit. But those are the solar cells that are much more complicated. And there's a bit of cheating there because you actually stack multiple solar cells that are responding to different range of the different light, and combine them into one and count at one device. Of course, in those cases, the theoretical limit would be higher.
You can also do solar concentrator. If you take a magnifying glass and put it on a solar cell, you can beat that 30%. But that's cheating. It works, but it's kind of cheating.
That breaks the thermodynamic limits of solar cell.
So this is it, final boss?
Yes.
All right, let's do it.
That's not a good beginning.
So if you're NASA, you can buy a greater than 30% efficient solar cell. Like their Mars rover has a triple junction solar cell that's probably
Do they really
40.
use?
Yeah, I think they do.
But how about the lifetime of those solar cells? I thought NASA still uses single crystal silicon.
Do they really? I could have swore they used multi-junction.
Really?
The efficiency was actually an issue.
Okay.
But who knows? I mean, I'm sure they have the optimized, like, price is no limit. You pick up and threw that dude. All right, ladies and gentlemen, anyone just joining us, Ask a Scientist Gaming. We have mediocre gameplay with expert level science. Hanwei is speedrunning Captain Commando with cheat codes of infinite lives because he just died again. But he's also answering questions about solar cells, LEDs, photonics, plasmonics.
Yeah.
All things science related. If you guys have any questions, throw them in chat.
Stop. What?
Oh, you did it?
Yeah, did it.
There we go. 38 minutes. Not bad. I don't know.
How many quarters?
I have no idea. We should add somebody to keep track of that. Captain Commando, what is the speed run? Sorry, we're going to look up the speed run right now. Captain Cap T AIN. And there it is. The speed run for this game is 19 minutes.
Not too bad.
So they took half as much time as you without cheat codes.
You know, scientifically, we call it in the same order of magnitude.
He's within an order of magnitude of success. Ninja Physics, thank you for redeeming Take a Drink. Cheers, Hanwei. Thank you for playing. Thank you for doing Captain Commando all the way through at twice the speedrun record. Within an order of magnitude of that Captain Commando player on the planet Earth. So, thank you for
I think that's totally within the error bar.
All right, so I think everyone knows what's coming next. Captain Commando is done. It is time to win the war on drugs yet again on Ask a Scientist Gaming. Hanwei, you're back to the other NES controller. Ladies and gentlemen, Ninja Physics, you got it right. It is time to get back to NARC. A-Rob, thank you for the 5 gift subs. With that, we are over the 50 sub mark. We are going to have 5 emote slots, so congratulations to anyone that got the gift subs from A-Rob. Alex, thank you for your contributions. Shmonite, logarithmically close time. You were logarithmically close to the record on that one.
Yeah.
But now, it is time for NARC. You ready?
Yep.
All right, let's do it. Yes, we have 5 emote slots now. If you guys have any ideas for emote slots, in particular, we need one that's a good game or some celebratory thing mildly related to science and or the stream. It'd also be nice to have one that's, I don't know, OSHA related. We had one with Pepe the Frog, but racist hijacked that, so we're going to avoid Pepe for obvious reasons. It's tragic, but so it goes. So yeah, if you have suggestions for emotes, join us on the Discord. Throw your suggestions in the suggestion channel. We would love to see them. But yeah, ladies and gentlemen, this is NARC. I can't remember what year. This was like 1985. This was an arcade game that got ported to the NES, and it's our tradition to play this at the end of every night because I don't know why.
Can you tell me what's the point? Meaning, what am I doing?
Those are all drug dealers, and you are trying to get to the end of the level. So killing these guys doesn't give you anything but points.
So I should just, go?
Yep, go to that door, see the exit door. Yep, just keep going.
I love this game.
We are rehabilitating them in quotes. Oh man. So speaking of factoids, so I saw a recent survey result that said 83% of Americans think the war on drugs has been lost. It is an abject failure in basically every metric. And so,
Yeah?
Yep. Maybe the success emote can be a stack of cash that is yet to be earned by patents. It's not bad. The patent emote somehow convey it's a patent making money. I like it.
Never mind. If you're talking to someone who didn't earn any single penny on patents, so.
Yet.
Oh, yet. I like that. Thank you for being encouraging.
I'll be the optimistic one of the two of us. The stack of cash is a good idea. But yeah, 83% of Americans think the war on drugs has been lost. And yet we've spent something like $5 trillion on it over the last 30 years. No, 50 years. So yeah, this game is a byproduct of the war on drugs. So thank you, Nancy Reagan, for directly contributing to the formation of the game NARC, which Hanwei Gao is playing right now. I don't want to be disingenuous to the war on drugs. It's been very good at a few things. Putting people in prison, militarizing the police, controlling minorities. That's what the war on drugs has done. But I won't rant too much because there's a new... Did you see the new law in Florida signed by DeSantis where faculty and students have to declare their political affiliations?
Oh, really?
Yeah.
When?
That was like today he signed that. So you have to declare political affiliations and also allow students to record professors without them knowing so they can share it on the internet or something.
Wait, what's the point?
It's basically the idea is that academic centers are liberal bastions that are brainwashing kids. So he wants to make us stop brainwashing kids.
But disclosing that doesn't really do what he
I mean,
intended.
The recording without permission I could see working against you, right? Because there are some portions of a lecture that taken out of context might come back to bite you in the ass.
I'm glad that I'm teaching.
Yeah, exactly. I'm not teaching religion or political science or,
I know.
Well, with that said, I rant regularly in class about people not voting and things like that. So, you have a blue card. Check if you have. Go up to that.
Oh.
So you might have to keep walking and or killing people till you get a blue card.
Okay. So some of them have blue card in.
Yep.
With them.
Yep. So yeah, it's probably unconstitutional and it'll definitely be challenged in court, but that is a law that exists in Florida now instead of signing fairly recently. So,
do we need to take any action?
I don't know if we're going to be asked to formally take some paperwork that says we are a certain political affiliation, but maybe.
Political? Oh, so it's not the political perspective, it's the official affiliation.
I don't know. It's so ambiguously worded, it's probably going to mean nothing, but it's just posturing for political rights.
Man, our governor is busy. I mean, he's signed a lot of bills.
Yep. But I will change the subject very quickly because that is all super depressing. But heads up, anyone in Florida.
That's fine.
Exactly. Yeah, he wants to run for president. That's exactly what he's doing. It's all empty posturing that's just going to cost the taxpayer for lawsuits that are going to go. Have you?
Well, it's all GDP.
Yeah, exactly. So go back to the left. Maybe we missed a blue card somewhere. Anyway, we'll get back to the science. That's my rant for the day. That was very frustrating to read. I don't know the details. I haven't read the actual law, but heads up, students and faculty at Florida that might be affected by
also
this.
Students.
Yep. All right, let's do something
Isn't
much
that
more...
some kind of privacy?
Yeah, no, it's going to be very unconstitutional, but it's going to take time for that process to happen. Anyway, Hanwei, more lighthearted. What's your favorite equation?
Schrodinger's equation.
Schrodinger's equation. Why is
Yeah.
that?
Because that defines, well, you can consider that's one of the most important equation in quantum mechanics, and that lasts to the development of the current technology. To some extent.
So maybe try bullets instead of rockets.
Oh.
So hold the shoot button instead of tapping it.
Oh.
Maybe that drops more. I don't know. I've never tried to rocket everyone. So we've added Game Genie codes. We have infinite rockets and infinite bullets.
So yeah, Schrödinger equation and also Maxwell's equation too.
Maxwell.
Yeah.
There's several Maxwell's equations.
4. It's a set of equations.
I believe so, yeah.
Yeah. And that solves essentially most of the electromagnetic or electrodynamic problems, which really set the basis of my research field. So Schrödinger equation solves a lot of problems in quantum mechanics.
Right. I picked it up.
Okay, let me pick up these ones.
You don't need any of this stuff. Always being thorough in our war on drugs.
Oh, here we go.
There we go.
Yeah.
Nice.
And that led to the development of solid state, the modern solid state physics, and then semiconductor physics, and then semiconductor technology, so on and so forth. And here you go, you're using smartphone.
That's a good point.
Yeah.
Sad. Euler's only, no fans of e to the IP plus 1 equals 0. No, I think several people listed that as their favorite equation. But Schrödinger's equation is one. Gibbs free energy is another popular equation. Entropy
yeah.
and enthalpy. That's Scott's
That's certainly important too. Yeah.
That's Justin Kennemer's favorite as well.
Yeah. Well, Schrödinger equation. The reason I like it is it's so simple.
Yeah.
But it's so significant, and it solves complicated problems with such a simple equation. It's impossible. I mean.
Oh. Rob has a good suggestion. Y equals mx plus b. That's a pretty useful equation.
I can't deny that.
that one's pretty solid. Thank you, Alex. I mean, that one's kind of universal because you convert a lot of things to y equals mx plus b.
God,
Also jump. But here's what sucks. So you're going to drive along and you're going to just run into a wall. That's what happens every single time. Controversial take. Triangle inequality is greater than any equality. I don't know what those are.
Was that?
A straight line, who's excited? When I teach Gen Chem, one of my themes is straight line graphs, because that's what you do in a lot of Gen Chem, right? In terms of enthalpy and entropy and kinetics, you try to make a form that gives you a straight line. Those are always exciting. But yeah. The equation question is a fun one, because it really depends on your discipline. The sum of any two sides of a triangle is larger than the remaining side. Yes.
That's a great one too.
That's a solid.
But that only applies when you're on a flat plane. Flat.
The triangle has to be on one.
No, can be on a curved surface.
It's not a triangle anymore, is it?
It is still. I mean, it depends on how you define surface.
Yeah, that's pretty fun.
Yeah. Surface doesn't have to be flat. And doesn't have to be linear.
All right, it's 10:33. We are due for another question. Which one do you want to do? Greenhouse gas or number of atoms?
Oh, number of atoms. Let's do that.
All right. All right, time for some more standard internet unit betting. We're going to do this one based on number of atoms. 2 minutes. Start prediction now. All right, so the question is up. And that question is, how many atoms, what is the number of atoms in a 5 nanometer cube? So 5 nanometers by 5 nanometers by 5 nanometers. How many atoms can you fit in that space? Is the answer greater than 500 or less than 500? And So this one harkens back to quantum computing, and I don't know why you're going backwards. Just keep going right. I know you love murder.
Look for the blue card.
There's no card on this one. Just keep going right.
5 nanometer is the most advanced. Well, it's probably the state of the art.
So this is, again, the question is number of atoms in a 5 nanometer cube. 5 nanometer by 5 nanometer by 5 nanometer cube. How many atoms can you get in that space? Less than 500 atoms or more than 500 atoms? And this is assuming not like black hole type matter density. We're talking about actual like atomic bonded structure like diamond or silicon or
In
something
our
like
world.
that. Yeah, in our normal physics that doesn't create a black hole.
I had another prediction which I got rid of.
What was that?
Is the how many atoms can actually fit within the same volume in black hole.
That's fun. Ninja physics. Apparently, I forgot how to read less than and greater than. I apologize.
I need some time to calculate that.
It's the alligator eats the bigger one. It's what our developmental psychologist would tell us. Well, look at you getting the car going. Oh, you had to crash it there. You didn't have a choice.
Yeah.
But I think you rode the car more than anyone on Ask a Scientist Gaming. So.
Oh, really?
Yeah. Not only did you speed run with an order of magnitude Captain Commando, but you have also rode the car longer than anyone.
Good.
All right. So the prediction: number of atoms in a 5 nanometer cube space. The answer is greater than 500 or less than 500. What's the answer?
Oh, it's already time.
Yep.
Okay. It is much greater than 500.
How much greater than 500?
So it's 50 by 50 by 50. So that's about 2,500. 12,500.
Roughly 12,500. So way more than 500 atoms, which means there is a whole lot of computational space within that 5 nanometer cube.
Mm-hmm. So the reason, well, I didn't really specify which material that we're talking about or which atom that we're talking about. But generally speaking, in most of the crystals, the spacing between the atoms are roughly angstrom, which is 0.1 nanometer, which is 10 to the minus 10th meter. That's just, happen to be that range for most of the materials that we encounter on a daily basis. So 5 nanometer is 50 times of that linearly. So 5 would get to 50 times 50 times 50. Did I do it right?
So, yeah.
5
50 by 50.
25,000. Yes.
50 times 15. I'm not gonna.
No,
That's 125,000.
Yeah, 125. Sorry,
125,000
I was wrong by one order of magnitude.
in that space. So Steve Leonard had a similar question. It was related to Feynman when he was talking about, using bits in that space.
Oh.
And when he does the math, he basically uses a 10 atom buffer around a single computational bit, and that's like computational power in a small space.
Okay.
Are you sure we can't pack them more tightly?
In the real world, marginally.
I mean, you can press the shit out of them.
You can press them. It's not going to make much difference.
Yeah.
Maybe a few percent at most. So when the reason that you can't really compress them too much is that the repulsion between the atoms becomes dramatically high when the distance becomes shorter. So you can't really compress them in the normal world. But of course, in stars, like neutron stars, that's totally different. The materials comes to a very special state called degenerate state, that the electrons are all stripped off from the materials. The neutrons are packed into extremely high density because of the gravity. So a
a table. Well, no. So a neutron star. If we make a sun, the mass of the sun into a neutron star, that'll be about 10 kilometers across.
Of material.
Yeah.
Huh.
So if you compress sun into 10 kilometers range, you make a neutron star.
Huh.
But the sun is about 100 times bigger than the Earth on a linear scale. So you can imagine what is the density of a neutron star. And that is amazing. That's a different state of material, which does not exist on the Earth.
Hanwei, do you want a hint on this? Yep, you gotta go in one of the doors. That's where the key is.
I was okay.
Yeah.
I was looking for I was waiting for someone who came with a blue card.
Yeah. Nope, you gotta go through the door and kill someone. I don't know where. There it is.
Thank you for being patient.
Hey, Rob. But what color are those atoms? I think the answer is black body radiation. They're glowing
Wait, which atom?
if you press them enough.
Oh yeah.
You can press them.
No, those are not really atoms. So those are. Sorry. Is he asking about the neutron star?
Yes, I presume. It was a follow-up to our earlier color of atom.
Then we shouldn't call them atoms anymore because it's really like just neutron.
Yeah.
Yeah. So it lost the structure of the atoms because the atom is the neutron, proton, electron, and of course, if you ask my high energy or particle physics colleagues, there'll be a lot of other ons in it.
Just keep going.
Wait for the blue card. Someone has a blue card.
Did you not pick one up already?
I don't think so. Maybe the other door.
Oh, back in again. I think you might have picked it up already, but we'll see.
Did I like this game. It's so brutal.
Yeah, no. This is ruthless. This is the war on drugs. NARC every single. Wait till you get to the boss,
Wait,
man.
how did I?
So stop pressing up after you go through the door. All right, anyone just joining us?
Apparently, you played the game.
Oh, I've played this game a lot. I'm the one that played it first. All right, so check if you have the card. You haven't. We play this every time.
I like
know
this game.
pretty well. All right, anyone just joining us? Ask a Scientist Gaming mediocre gameplay,
mind
expert level science. Oh yeah, absolutely. That is the point. So here, I'll do a redeem a drink for you, so you have completely justified standard internet unit reason to drink that. Hanwei, cheers.
Cheers.
Thank you again for joining me. Ask a
Thank you
Scientist Gaming.
for hosting.
Thank you for playing NARC. I have yet to be turned down when I suggest we play a crappy game at the end of the night. So here it is.
I love this game.
It's a favorite.
I love any game that it doesn't ask me to put in coins.
Yep, go to the right.
Thank you for reminding me again.
Go to the right.
I'm so into
You're just
killing
murder.
them.
Just murder. No, this is like the real war on drugs. Oh man.
Oh, the door. I didn't
Yep.
see that.
Oh, so now you got to go left. I don't know. They changed it up on this level. All right. Does anyone have questions for Dr. Hanwei Gao, who is
Please.
a condensed matter physicist who likes to talk about photonics, plasmonics, solar cells, LEDs, perovskites, anything you might want to talk about? Now you have to kill the guys, the Rambo-looking guys that run across the screen. So I'll throw a question out there. What research are you doing right now that you're super excited about? Like, what's your next big thing, your next major proposal? What's that moment for you?
It's to give the perovskite new life.
New life.
Yeah.
It's got pretty good life already.
Well, not enough. From a scientific perspective, I believe this material has more potential. It's unusual, not because it's useful. It's also because, fundamentally it's unusual. It contains both organic and inorganic components, and you can put those into a crystal structure. I'm not saying this is the first time people found out about an example of this, but this is this class material is certainly one of the ones that is so easy to control, so easy to tune. You can manipulate many aspects in terms of the structure of the material so that you can basically tailor the material, give the material the property that you're interested in, instead of purely discovering.
Yeah.
Yeah.
I want you to reveal too much about your research, but how are you going to give it new life? You don't have to.
So one thing is that these materials have been used a lot for photovoltaics, but in the meantime, they can exhibit properties like ferroelectrics, piezoelectric, or when you're talking about ferroelectric, you're breaking the symmetry of the crystals, so they can also exhibit spin-dependent properties and make it useful not only for electronics but also for spintronics. Spintronics is a different category of if I call it electronics, some people would get offended.
Yeah.
But
I just call it quantum computing. No. The new one is quantum information sciences.
Yeah. Well,
Anytime you can control
basically,
spin,
basically you're not only
information.
controlling the charge but also the spin of the electrons
Yeah,
to make it functional.
it's a hot area right now.
Exactly.
Big.
It has been a hot for in condensed matter physics, and also a little bit into the chemistry as well.
Yeah. Well, it's
Yeah.
blowing up in chemistry now. Like the NSF Graduate Research Fellowship said, we're going to favor quantum information related things.
Really?
Yep. Yeah, so it's getting serious.
Can they really say that?
Yeah, they did this year. People were upset, but they did. I don't know how much they followed through with it, but yeah.
Well, NSF now gets money.
We'll see. New budget. So you were on the last level. Now you got to climb the tower of Mr. Big, the big boss man at the end of the game.
Mr. Big.
I'm excited for you to meet the final boss of this game. Go in the door.
How many of your previous
How many people have beaten it?
Yeah.
I think everyone does.
Oh, really?
It's infinite lives, infinite ammo.
Yeah, that's where I'm going to, is to deviate a little bit from the mainstream of the research in perovskite, but
Yeah.
look into other interesting physics that this material can sustain.
I mean, I'll be curious, like putting a organic radical in that lattice or something with spin associated with it, combined with the photochemical, like
you get the point.
you can do weird stuff.
That's why this material is so interesting, because
Yeah.
it contains the organic components, and any organic, well, not any, but a lot of the organic ions that can fit into the voids,
Yeah.
size-wise,
Yep.
into this crystal can be incorporated into it, and you can design the ligands any way you want.
So the
With
hard
the
part
spin.
is measuring that afterwards.
True.
I mean, there's optical, but also magnetic properties you have to measure.
And the material is not stable. So it's not like you make a device, you can measure it many times. You have to,
Just hope.
the clock ticks, so
Well, so you'll have to like distribute those spin states throughout in a distance they don't communicate and all sorts of, yeah. No, we're looking into this area too because it's so popular.
really
But like putting it on interfaces.
cool.
Yeah.
We should talk more.
And we should. We talk regularly.
Yeah.
All right, let's throw one more prediction up on the board since we have it.
Is that the
kind of a
last
fun
one?
Yep, this is energy related. Again, conservation of energy, where energy is being spent. Our final prediction of the night, ladies and gentlemen, we are going to do one regarding greenhouse gas emissions. All right, so prediction is up on the board right now.
I like this one.
So, the prediction is... Sorry, I gotta get that out of the way. The prediction asking, which is producing more greenhouse gases in 2020? Is it agriculture or transportation? Which one emits more CO2, CO, NO, all the greenhouse gases? Which one does it? Is it agriculture, which includes, I guess I don't know what agriculture encompasses in this case, but everything from cows farting to processing those types of meats versus transportation. And so transportation Obviously,
Also, burning the I guess, like, not really the woods, but just to create lands.
the biomass. So
Yeah.
clearing fields for agriculture versus transportation. Which one generates more greenhouse gases? Is it agriculture or transportation? You have that key. So just go to the door. You'll have all the next keys until silver. I should write a walkthrough for this game.
You should just let me go. I'll probably play the room forever.
We're going to be here till midnight playing NARC. So again, the question is, you have about 45 seconds. Which one generates more greenhouse gas emissions? Is it agriculture or transportation? And this is in the U.S., presumably. Or is this
Globally.
globally? This is globally. Okay,
Yes.
globally. Agriculture versus transportation. Which one creates more greenhouse gases? What about tractors? Isn't that transportation for agriculture? Oh man, you just got loopholed.
I like that.
Polymer's rule just stomped on your question.
Wait, is that a comment from audience?
Yes.
Really? You got great audience.
Clever as hell.
I know.
You are the student, so you're the student I would give credit to for that response. 'Cause
Yeah.
that is more creativity and better.
It's certainly critical thinking.
Man, so I have this really bitter story from when I was a graduate student in TAing.
Uh-huh.
And there was a question on a test, and it was, how do you double the production of a certain product? And the answer they were looking for is, increase the temperature by 10 degrees, increase the amount in Le Chatelier's principle, and shift it. But one person wrote, and I was grading the test, they said, build a second reactor. And I'm like, you are a goddamn genius.
I know.
Because you have doubled the production. And I fought with that teacher for at least a week trying to give that student points, and they refused to. And they're like, well, that would cost more, blah, blah, blah. I'm like, you didn't say any of that shit in the question. You just asked, how do you
Exactly.
double production?
Yeah.
That was the loophole.
I think creativity is really needs to be encouraged in those cases.
Oh,
You
absolutely.
don't want to restrict students' thought in that sense.
No, exactly. So polymer rules, you get extra credit points. But Hanwei, what is the answer? Which produced more greenhouse gas in 2020? Was it agriculture or transportation?
Transportation.
Transportation.
Yeah.
Transportation by far?
Yeah, by far.
Like order of magnitude far?
Oh, you mean by how much?
Yeah.
Not so much. It's probably not as. It's less than twice.
It's less than twice. Okay, so it is fairly close.
It is very close. The point I brought up this prediction is in a lot of if you ask a lot of people, they would just exaggerate the impact of agriculture on greenhouse emission, and I get the point because a lot of people, especially I think in the U.S., the agriculture greenhouse gas emission is overlooked significantly. But just because of that, we should not misinform people on that.
Yeah.
Because that, I believe, that actually is counterproductive. Because people find out that's not true. And then once they find out, what would they think about that? Any reporting that they would not believe
You
it.
got him. So here you have to shoot the guy in the wheelchair with a rocket in order to get the gold safe card. So he'll come back. You have to shoot him 3 times.
Did I got?
Yeah,
Did I get him?
I think you asked. There he is. There he sniped again. 2 for 2 on the clips, and then you see him crawl away. You are crushing it, Hanwei. I
Accidentally.
don't believe you. Your entire childhood was spent playing video games like this. All right, we'll close with a few additional questions. All right, if you could completely change your research, as in you couldn't do physics, you had to do something else. You could do, I don't know, chemistry, psychology, biology. What would you go for? What would you take another 5 years to learn and become an expert in?
What would I take the next 5 years to become?
Yeah, like if you could go back and do a PhD, what area?
I want to be probably a biomedical.
Biomedical?
Well, I always want to do medicine.
Yeah.
Yeah, because that's the thing.
Well, let me go back to step back a little bit before I answer that question. I want to do something that is very impactful to people's day-to-day life.
Yeah, like immediately impact.
Exactly.
Like
So
actually
medicine
make a
is something
difference.
that you can exert that impact.
Nice. There he is. You got him. He turns into a gold bar. Get the safeguard. All right, ladies and gentlemen, we are on to Big Boss Man. Are you ready for Mr. Big? I don't think you are.
Wait, I thought that was.
No, Mr. Big is coming.
Oh, really?
Yes, the final boss of NARC is up and coming.
Yeah, but am I really gonna be good at medicine? I don't know.
I'm guessing your bedside manner is not going to be great. Okay, so Mr. Big, you have to jump and shoot him like in the top of the head.
Oh,
So you have to jump and then rocket him in the head. So turn back, jump, and then rocket. There we go. Glasses off. Step 1 of Mr. Big. So you got to do that again until he exposes the skull and then shoot the shit out of his spine. Well done, sir. Glasses off on like 3rd try. That's it. That's his tongue, by the way. All right, you go into biomedical. I mean, you could do biomedical research and not interact with patients, but still make an immediate difference.
yeah.
Like testing and things like that. So, oh, there you go. All right, now shoot his spinal cord, shoot his vertebrae, and they're going to disappear over time. All right, we have last 5 minutes. If anyone has any final questions for Hanwei Gao, he is trying to fight the skull of Mr. Big, the final battle of NARC, before we call it a night at approximately 11 o'clock. If you have any last minute questions, throw them in chat. If not, I have one last question. What is your pet peeve in the field? In terms of nomenclature, lack of controls, what are people consistently doing wrong that you see in the reviews? Before we do that, Alex Robb is redeemed. Take a drink. So, cheers,
Cheers.
Mr. Big.
It's the biggest pet peeve.
I mean, so Perovskites had a big problem because they accelerated in popularity so much before you could establish standards in the field.
Yeah.
And it was just a mess of reporting and measurement. And
I totally agree with that, and that's something that's in the direction that I'm thinking about.
yeah.
Definitely, people needs to be more rigorous in reporting their results.
Yeah. So we have a general problem in solar cell and OLED community, or LED communities in general. There's something called a hero device.
Yes.
Where it's the best thing they've ever measured out of 50 samples, and that's what they report.
In the field of perovskite, it's even worse.
Yeah.
It's not about hero device. It's about a hero device at a hero moment.
Yeah, because it changes over time as you measure it. Oh, you need to do bullets on the spinal cord. So yeah, you got to get like to the side of them and just shoot a little bit
Wait,
high.
where on the
Like,
spine?
In that. So if you go a little high, there you go. You saw the points show up on the screen. There you go. Nice. But yeah,
Wow.
here. Oh, there it is.
Oh, wow.
Let's crush that.
Yeah, I
Big
thought I would
boss
need to
man.
shoot at the colorful eyes
Yeah. No,
with
we
the
need-
rocket.
This is why we need a GG emote, because Hanwei, you are ahead of schedule, 3 minutes. But now you got to go exit.
Awesome.
All right, so hero device measured at the right time, and then
Yeah.
you report those numbers like those are some kind of standard behavior.
Mm-hmm.
And that's obviously problematic for a lot of reasons.
So, would I destroy the field if I say too much?
I don't. It's going on YouTube, so it's up to you how much you want to say.
No, I mean I think people in this field realize that's a problem.
Yeah.
Because certainly this materials have brought so much potential and promises to the field, and that's real.
Yeah.
Okay, I'm not saying
Promise
that.
is real.
Yeah, I'm not saying that it's all fake, but the problem is that people are too ambitious sometimes to report, and that comes from the competition because of the potential of the material.
Yeah.
A lot of people are coming after this class material, so that raises the competition in this field. And believe it or not, research is a profession. It's not just only curiosity driven.
Mm-hmm.
You need to deliver. You need to have product. Therefore, I think that partly contribute to the.
Not quite done yet. You got to collect the gold. You don't have to collect the gold, but you might as well. You earned it. 24,000 in gold.
Oh,
but sorry, go ahead.
That's more than my royalty. Yeah, so there's a reason that people are eager to report higher numbers in terms of the performance, etc.
Yeah.
But
It's bad for the community.
That exactly, and it's not really moving forward the progress, the understanding in this field as much.
Yeah.
So at some point we need to stop. We need to calm down and think about what is really the fundamental questions.
You beat it. So heads up, if you put an ass, you double your score. That is my favorite factoid from this game. Nope. What do you do? What are you doing?
PV.
PV? PV?
Yeah.
I like it. Then go to end. Man, your timing is perfect. It is 11 o'clock. You've beaten NARC.
Hey,
Congratulations.
it's all fabricated.
How do you feel?
It's great.
You won the war on drugs.
Yeah. I love this game.
The license plate says yes, say no. You won it. PV was the appropriate choice. Thank you, Ninja Physics. All right. That's it. 3 hours up, 3 hours down. You did 12 levels in Bomberman. You beat Double Dragon 2. You beat Captain Commando. You beat NARC. That is a successful night of gameplay.
It's
plus
much
science.
better than I expected. I didn't believe that I could play games when I'm speaking. Maybe I didn't really speak anything that's meaningful.
Hopefully people got their answers, but again, thank you all for joining us. You guys check out the Discord. The link is in chat. You guys should join us, post questions, post ideas. Particularly, we're going to have 5 emote slots, so give us suggestions for what we should add for good game and success and just say no to drugs or whatever. Hanwei, thank you for joining us. It's been a pleasure. It's a successful night. Fun talking science. It's great to have you.
Thank you for the great questions.
Yeah, no, there's some really fun ones. They found
Colorful
a loophole.
atom. I remember that question now.
Yeah, the colorful atom as well as the tractor for agriculture. I don't know, broke my mind. No one
Exactly.
accounted for that math.
Yeah.
But thank you very much for joining us. The YouTube video will be up on Friday morning, so check that out if you missed anything. Other than that, again, thanks for stopping by. We're going to rate I don't know, we'll see, somebody science related. But we'll do that post. But yeah, any parting words for...
Come back. We'll have better scientists to answer your questions.
Speaking of which, our next guest will be Don Carr, who's a sociologist who studies late life healthcare and late life caregiving and things like that. So yeah, sociology, we're going a different level of abstraction than physics. So it should be pretty fun, applicable to your grandparents, your parents, healthcare and things like that. So again, join us in 2 weeks. Again, Wednesday, 8 to 11. We're going to try to keep it consistent every Wednesday from now on. Check out the schedule on Ask a Scientist Twitch site or on Discord. You can watch either of those. Other than that, stick around if you guys want to raid another science streamer. But yeah, thanks for swinging by, and it's always a pleasure. Thank you for all the questions, and we'll see you guys in 2 weeks.
See ya.
Until then,